I finished looking at Verse, the programming language for like concurrency and effect systems, and before that I looked at async Rust, right, and then I was looking at category theory for programmers. So I want to get back on reading category theory for programmers. I also have some other books to get into type theory. So category theory is more just for general interest. I want to learn about category theory through the lens of programming, just because that's like I'm interested. I am interested in category theory beyond just mathematics. So I want to get it looks like a more approachable book for beginners. So I want to read that first. But after that, I want to read this book, The Types of Programming Languages by Benjamin C. Pierce. Apparently, it's a good introduction to type theory, or at least type systems in programming. Stuff like the Henry Milner system and whatever the hell Haskell has going on. And then there's also this book, which is the this one, The Formal Semantics of Programming Languages, An Introduction by Glenn Wiskell. Another book I want to read, because unfortunately I don't have the option to study any of these in university, so I want to, so it's kind of up to me to study them on my own, unfortunately. But today, or at least before reading that, I want to have a look at Koka, because I want to kind of finish off this effects programming. I mean, not finish off, but explore this effects programming more deeply, because Verse has effects, but Verse effects seems to be a lot more limited than other languages are. So I think Koka would be a good example. There's also Effect, which is as the name implies, another effect-based language. And yeah, maybe it'd be actually worth looking at that too then. So I'll probably look at that. This was a prologue for a programming logic language, but I don't really know where to start with that, to be honest. There isn't like a clear book of prologue that I'd be able to find. I almost feel I need some kind of preliminary knowledge, you know. So I'll probably just leave that for now. But yeah, Koka and Effect I want to have a look at. Hopefully I can get through both today, even just skimming through to the important parts. And yeah, after that I want to get back on category theory for programmers, and also get back on my game, but implementing concurrent systems, because I think that'd be fun to implement. So yeah, Koka. Although before that, thing is, there's type theory and then there's type systems, which are different from each other. So I believe type theory is a branch of category theory. You know, category theory is the ultimate topic, and then type theory, set theory kind of fall under that. Yeah. So I'll probably bookmark this one too. Have a look. Look, let me just ask. How does type theory differ from type systems? Or how do books on type theory differ from books on type systems? And I've been pinged apparently. Anyway, so Koka is a strongly typed functional language with effect types and handlers. So it's not effect-oriented per se. It's more that it's a functional language that has effects and handlers. Also, but it doesn't even say effects. It says effect types. So we'll see about that too. Also, by the way, if I start reading this and I'm just so lost on the theory, I'll probably leave it for after I read more of the books I have lined up. I don't know how long it'll take me to get through the books. Hopefully, because there are obviously a lot of pages, but it's not like reading a novel, because I don't know, like let's say like a novel is 500 pages, you know, so someone would come up and say, oh, I can finish that in 1 day or 2 days flat, you know, but this is like an academic book, you know, that could have like a whole university modules worth of contents or more, so it takes time to study those and like really really study them, you know, and like take like proper notes and like apply the concepts and stuff like that. So I expect it'll take a while, but hey, best thing to do is just go fast. Anyway, it is usable, which is actually good. I forget that these languages are things you can actually use, so I could install the compiler. Yeah. So if I feel like it, I can do that. I don't know how far along this language is in terms of development as well. And this is the GitHub page. Algebraic effects. Haskell. Seems to use GitHub pages yet. I mean, it's on 3.2.3, you know, and this was 6 years ago, so like it's at least 6 years old. Has 5,000 commits, 4K stars, and like it's on version 3.2, so like surely it's fairly quite along in its development, to the point where it's probably quite usable, isn't it? And it's in a Koka line. Yeah, so like it's more than just like a pet project. So I do hope that it's quite powerful, because honestly, like, I would love to use this for a while if I can. And then Effect as well, like, is Effect like anywhere near as far along? Many commits, again 6 years ago for the license. It's a research level language, okay. So like, yeah, okay, so that is, I guess, more likely to change, and it's written in Scala, 91%. That, or it just doesn't recognize Effect, but if you look at, yeah, no, it's okay, yeah, so that's in Scala. In fact, the website looks a lot like Scala, like inspired almost, but Koka seems to be its own thing. It is a research language, and it's currently under development, okay, and not ready for production use, okay, never mind. But it is stable, and the compiler implements the full specification, okay. It's lacking async libraries and package management. Right. So, why Koka? It's also one page. It is. There are many new languages being designed, but only a few fundamentally new concepts. Like Haskell with pure versus monadic programming, or Rust with borrow checking. Koka distinguishes itself through effect typing, effect handlers, and Perseus memory management. Whatever that means. So, the core of Koka consists of a small set... let me put my camera here, by the way. A small set of... I'll zoom in as well. Yeah, I was hoping that would, like, shrink. Okay. The core of Koka consists of a small set of well-designed language features, so that's too small, too big. Like first-class functions. The thing is, my computer's being really pixely right now, and I don't know why. Like, my recording is quite pixelated. Yeah. It's kind of annoying, but... I mean, I can do that. It's a bit zoomed in. Otherwise it'd be like this. In fact, let me just collapse this. Yeah. I don't know. Hopefully that's a bit better. Whatever. The core of Koka consists of a small set of well-studied language features like first-class functions, polymorphic type, and effect system. Why is there a dash there? Polymorphic type and effect. So polymorphic effects. Algebraic data types and effect handlers. Each of these is composable and avoid the addition of special extensions by being as general as possible. Okay. Effect types. Koka tracks the side effects of every function in its type, where here and if... Okay, then my monitor just turned off. Bro, what's this connection? where pure and effectful computations are distinguished. The precise effects typing gives Koka's rock-solid semantics backed by well-studied category theory, which makes Koka particularly easy to reason about for both humans and compilers. Right. Yeah. Category theory, awesome. Effect handlers let you define advanced control abstractions like exceptions, async await, or probabilistic programs as a user library in a typed and composable way. See, Verse had effects. I don't know if it had effect types though, and I also don't know if it had effect handlers. More so, it just had effects for like explicit API stuff. So I imagine that's quite different. But yeah, I know that there's exceptions, async await, and also like I/O kind of things, and that's interesting. Like I wonder what else you'd use them for. Because Verse doesn't let you define your own effects, but I think Koka does. Perseus is an advanced compilation method for reference counting. This has Koka compiled directly to C code without needing a garbage collector or runtime system. Okay, so already it's in like the same space as Rust, which is very good. I want more systems programming languages that compile to like, well, like it says here it says C code, but like compiles to like LVM or whatever, you know, for like systems programming. That's what I want. You know, more high level languages that compile to that. Because we go on like a stream of like Zig, Odin, Nim, but like those languages they just aren't particularly nice. Like they lack the abstraction power that other languages like C++ and Rust provide. So I want more languages that are like direct competitors to like C++ and Rust than like C. Because like C, like I don't care about, you know, like let Zig, Odin, C, Nim programmers have their fun. I want abstraction with performance and low level memory control when needed, you know. But then like the ability to abstract on top of that low level memory management. I don't know what Perseus is, but I guess I'll explain that later. And reuse analysis through Perseus, Koka can do reuse analysis and optimize functional style programs to use in-place updates. Let's see what that's about. So Koka has a small core set of orthogonal, well-studied language features, but each of these is as general and composable as possible. So we do not need further special extensions. Yeah, Haskell has like a lot of extensions, which I mean it makes sense for it as like a research language, but core features include first-class functions, a higher rank impredicative polymorphic type and effect system, the hell, algebraic data types and effect handlers. As an example of the min-gen design principle. What does that mean? Koka implements most control flow primitives as regular functions. What's min-gen? Is it like minimum like cogen? But like what's that even? Doing less is better. Okay. Koka implements most control flow. Yeah. An anonymous function. See, like while loops can definitely be written as functions, you know. And for loops, and then like you can create your own special types of loops, like having like a first loop, you know. Anonymous function can be written as fn body, but as a syntactic convenience, any function without arguments can be shortened further to use just braces. Yeah, you know, it's like blocks, right? But then how do you call them? I wonder. Moreover, using brace elision, any indented block automatically gets curly braces. Also, like, this is weird. What? Here says fn, then here this is fun. Or because like that's a definition. I've been thinking about like having consistent syntax. By the way, like you can have syntax be consistent in the sense that you don't have like multiple ways to do the same thing. Like for example, like having anonymous functions, but they're not having like this, you know, like function definition statements. But honestly, you can make exceptions. I think, like it's fine to make exceptions that like aren't consistent, where it makes sense. I think it's just like using it sparingly and using it to like good effect. Because like there are also advantages to having a consistent system, because it means that you can find ways to organize things that are actually way more powerful than you realized. Like maybe there's power in having classes, structs, functions, values, everything be assigned to an identifier, rather than having like these kind of top level definitions. So you know, some thought there. Or like there's you know, there may be power in having a main function as opposed to like a top level function file start thing, because then, you know, you could use that to say, well, okay, maybe my program is a module, or my program is a class in of itself, and it's just, you know, implicitly the main class, or I guess in the case of Java it could be explicit, that, you know, when something runs my program, it's actually just running that class, you know, or like accessing that class and running its main function. You know, like, you know, you could have that kind of design. Brace elision, any indented block automatically has curly braces. Okay. Right, so like, yeah. So it does use a significant white space to insert blocks, braces, sorry. But you can optionally also add braces anyway, which is interesting. So an indented block implies curly braces. That's good to know in general. You can write a while loop now using regular function calls as shown in the example. Where the call to while is your sugar to while fn that and then fn that. Oh, I see. That's quite cool. So this here is an anonymous function, and then this here is the function body, but also the function. So you call while with 2 arguments, and it's just that. That's pretty cool. So it means that this language doesn't have like trailing lambdas or whatever. It's just so that if I have an indented block, it's literally an anonymous function. And like you don't have to call this either, right? Like this is called by while, because while is a function. I wonder how that works. But okay, that's interesting. So before I go any further, let me go ahead and make a new source note. Also, by the way, I haven't added to my diary in like 5 days, or my journal, because I don't know, dude. I just haven't really thought to, and my motivation to isn't that high either. So this is the Koka programming language. I wonder why it's called Koka, by the way. So Koka programming language, authors, it says, is Dan Lejen, which looks like, whoops, which looks Nordic, or Scandinavian, I mean. Scandinavian. Netherlands. Oh, that's right. Okay, fair enough. 17th of March. This was last updated. 2026. Tags. It's like a. It's not a book. It's more of an article. I mean, like, the distinction doesn't really matter, but IDs doesn't matter. Link. Oh wait, no, it is book.html, to be fair. Okay, then I'll call it book. Okay. So yeah, here. No, here. Yeah. So we got Y Koka. Sorry, that should be here. What? The Koka programming language. Yeah, so Y Koka. Minimal, but general. Yeah, so it's very interesting how the use of brace elision is rather interesting, as it means that functions can be written like so, without any special like trailing lambda syntax. I hope Koka has highlighting. So we have a function hello 10. I don't know why I'm not just doing this. Hold on, should try this. While I less than 10. Yeah, print line. Print line. And it's also like normal function call syntax still, like to an extent, which is interesting. Equals I plus 1. So I'm gonna bind that operation there. See that there's no highlighting. Tragedy strikes. Yeah. I wonder if there's like extensions for that actually. If I look in community plugins and browse those, Koka, no, syntax highlight, no, okay, whatever. Put this in view mode. Yeah. It's like this desugars essentially to while function, you know, I is less than 10. Function print line hello. Let's copy that. Yeah, that's pretty cool. It's backwards. Although I do wonder, like, you could alternatively have it like this. Like, imagine if it was while I less than 10, print line hello. Like, however, one could argue that opting for more specialized syntax would be nicer, even if like less consistent. Or like even if, yeah. Not even like less consistent, just like not whatever. And this would be like Pythonic syntax. You know? I would prefer this syntax. Sorry, I'm covering my screen, aren't I? Yeah, I'm gonna have to like just do this, I'm afraid. But like I prefer this syntax to this one. I know it's really small on my screen, but okay. We can write a while loop now using, yeah, there's also naturally to consistent, yeah, that's the consistency. An expression between parentheses is always evaluated before a function call. Whereas the expression between braces, suspenders, what? Is suspended and may never be evaluated or more than once. So, and may be never evaluated or more than once, as in our example. This is inconsistent in most other languages, where often the predicate of a while loop is written in parentheses, but may be evaluated multiple times. Right. Okay. Yeah. I mean, that much is true. Okay. Why is it giving me so much like learn about, dude? But okay. Yeah, so okay, so basically it has braces be anonymous functions that are yet to be calculated, whereas parentheses are for things that are calculated immediately. Okay. So I like the rule, like the rule / distinction between parentheses and curly braces, or just braces. Yeah. So parentheses are evaluated immediately. Braces are evaluated. All braces, like anonymous functions, are evaluated when triggered. When called. When and if. If and when called, let's say. That's why while loops use braces other than parentheses. Other than how other languages use parentheses. Effect typing. Koka infers and tracks the effect of every function in its type, and a function type has 3 parts: the argument types, the effect type, and a type of the result. Right. Argument types, effect type, and the type of the result. So for example, function square, int to total int. Mathematical total function. Right, so the effect goes before the return type. I wonder how that works. Because, like, it doesn't, like, does it wrap it? I don't know. Divide exn may raise an exception, so it's partial function, okay. Yeah, I just don't like exceptions, but we'll see how it does exception handling. Because I don't like try catch. Turing may not terminate, diverge, right? Print may write to the console, that's oddly specific, and rand non-deterministic, okay. This precise effect typing gives Koka rock-solid semantics and deep safety guarantees, backed by well-studied category theory, which makes Koka particularly easy to reason about for both languages, for both humans and compilers. Given the importance of effect typing, the name Koka was derived from the Japanese word for effective. That's cool. Right, so it's Japanese and it means koka. Or it's koka. Good. I wanna get back on studying Japanese so bad, but like if I don't have a reason to read Japanese, I'm not gonna read it, you know. I don't know, man. Like I wanna. Cause like Japanese is just such a cool language. And I say like Chinese too. Like English is cool and all, but like these 2 languages are particularly interesting. Is that just show? That was Google Translate, pal. Okay. Effect typing. The namesake for Koka comes from the Japanese word. I guess. Koka. Meaning effective. Okay, a function that any effect is called total and this corresponds to mathematically total functions. We've got a good place to be. Then, okay, so there's no like implicit effect. But why is total an effect? I wonder. They may have effects for partial functions that can raise exceptions, and potentially non-terminating functions as divergent. To be fair. The nice thing about an exception system versus like result types is like sometimes result types aren't partial, and sometimes they are, right? Like sometimes an error returned from a result type is like pretty much intended to terminate the program, and therefore like your function is not partial. It can fail and fail the program. Maybe you handle it nicely, but like either way it still fails. Whereas I could have like a division by 0, rather than be an error, I could just have it be undefined and say the option, and have it be an option result that returns nothing. And you may treat that, or like think of it that as like a result type, right? Like, yeah, you know, like it's an error, so it returns none, you know. But no, you could just define division such that it either returns something or nothing, and then that's just like, that's total. Like, that is mathematically sound. It could just be that there's none. Like, it's not an error. It's just that there is no result in that case, you know, which is interesting. Or of course, just don't allow the function to take an argument as 0 anyway, and then that'd be a compile error. But then that way you avoid having runtime errors, and then your only runtime errors are like, not even really errors. They're more just like partial. Not partial. They're more just like, I don't know. It's just things like, if a file, but like, I mean, but like there's some things you can't really check at compile time, right? Like if a file fails to load, right? That would be an error. But then, like, would that be like through an exception, or like if allocation fails, would that be an exception as well? This is so strong. In a good way. The combination of ex10 and div is called pure. What? What? That corresponds to Haskell's notion of purity. On top of that, we find mutability as st, up to full non-deterministic side effects in IO. Bro, what? What is Huh? How is a partial diverging function pure? I don't understand that, but I guess I'll explain later. Effects can be polymorphic as well. Yeah. So here you have a polymorphic effect, E. Okay. Match x's, cons, x's, xx, sorry. Nil, okay. Okay. So there is a rule that single letter types are polymorphic. Right. That's interesting. Like, I've been thinking like how you should do generic type arguments. It's not ideal to have them be single letters, because like that's kind of hard to read, but like E here stands for effect, you know? Or maybe I want, like, you know, E1, E2. Maybe that's an idea, actually. Like, instead of having like A, B, E, whatever, have like T, like have E for effects, and then be like E1, E2, E3, or like E, E2, E3. For types, have like T, T2, T3. Is that it, actually? Yeah. And like for size, I don't know. Or like for like context for variables, if that's even a thing that would happen in this language, have those be like V1, V2, V3, you know? It's an idea. Probably harder to read, but yeah, anyway. Effect handlers. Instead of various special language and compiler extensions to support exceptions, generators, async await, etc., Koka has full support for algebraic effect handlers. Yeah, so I didn't know that you could, at least before hearing about this, I wasn't aware that you could make such a generic, like, abstraction over exceptions, async await. I don't know what generators are, but it's interesting. control operation int value. Effect yield, CTL yield. What? So a control operation is something else, I guess. Also, by the way, I have actually looked at a language that has effects called Anti, but that one's, I think, a lot less developed than this is. And I was definitely more confused after reading it. I think because I lacked a prior introduction to what effects systems even are. So traverse can yield, but it yields a unit type. If yields X, then traverse XX. So traverse calls yield, and therefore gets the yield effect in this type. That is a bit confusing, having yield and yield be like the same identifier for different things. If you want to use traverse, we need to handle the yield effect. Handle, okay. This is much like defining an exception handler, except we can receive values, here an int. I don't understand where the int's coming from. Effect yield, CTL yield. Wait, what? We need to handle the yield effect. Yeah, sorry. We can resume to the call site with a result here, with a boolean that determines if we keep traversing. So print elements with CTL yield I, print yielded plus I dot show traverse 1, 2, 3, 4. Wait, so that's the effect handler, right? Written in the with statement. Okay, so what I don't get is that traverse yields nothing. Supposedly, it's a unit type, but then here, oh, so why is it a bool? Sorry, I don't know, whatever. Okay. Oh, it's more training. Okay. The with statement dynamically binds the handler for yield control operation over those of the scope. In this case, that. Over the rest of the scope. Okay. Resumes to the call site with a boolean result. Resumes to the call site. Oh, okay. I see. So we're defining yield here. Okay. That's the argument that's being passed. I. Or like we're binding to it, whatever. We print that, right? And then we resume I is equal to 2. So we resume if I is equal to 2, then traverse further. Okay. I see. Is it like an online compiler? Because that'd be really nice, wouldn't it? Yeah. Right. That's cool. So what's cool is that this is like almost like a try block, but like it's just the whole scope. I don't know. Because like my main issue with exceptions isn't like the whole like, I don't know, stack unwinding, whatever. My main issue is that it's just like, I don't like its control flow. Like it just reads badly. Like having try catch and then like the, you know, and like you can read through exceptions by just doing try and like catch all and throw those, or like having, and like the way it indents the entire scope as well. And like if I want to just try like certain things and like I have to write like these try catch expressions that are like really long, it's just really bad. And like most languages that have exceptions just don't have good syntax for it. Like it's just really annoying. But then result types just feel a lot more like intuitive, you know, like you just return an error and then it propagates through because you propagate it, you know? And then having like, I mean it's all great in C++, but like in language like Rust that has the question mark operator to help, you know, early return more easily. Like it just works a lot better in a language that has good syntax for it. I haven't seen a language that has exceptions with nice syntax yet. So maybe this language could change my mind, you know? Could change my mind. Online Koka compiler. It's been 6 years. Okay. There's Koka. We have a weird way to do it, but okay. I see. There's Hello World. So, I'm guessing yield's already been defined. Yeah, okay. It's kind of hard to test this, to be fair. Right. Anyway. But yeah, this is interesting. I like plus plus being the concatenation operator. Is it only on strings though? I hope it works for list, like just list in general, or like concatenable types. Okay. Perseus optimized reference counting for automatic memory management. Oh. Okay, so like it's a bit slower than Rust and C and C++, because those use manual memory management. Right, it's reference counting. Yeah, no, that is slower. I think Swift does, right? Does Swift use Perseus? Reference counting. Seems not. But yeah. Because because like Swift also isn't garbage collected, but it's still a bit slower than like C++ and Rust, simply because it uses reference counting. But like it's still faster than garbage collection, which is why I'm more open to the idea. Especially like if it gives you facilities to bypass it and go manual in some cases. But I don't know. Okay. Within 2 times of the performance of C++. Initial benchmarks are encouraging and show code to be very close to C performance on various memory testing benchmarks. Okay. I don't know why I could open that in a new tab. Okay. Holy moly. Why is C++ so much faster here? For deriv, I mean, I'm not familiar with these, by the way. I think nqueens is the only one I actually know, but Somehow in deriv, Java's faster? And C++ is slower? Which is very weird. Yeah, how slow is Swift? I thought Swift was like competitive. But it's like the worst in like all of these. Even Haskell is better. But Koka without optimizations is also quite slow. But obviously with them, it's fine. Which is X. Like, what does that mean? I guess like not comparable. Okay. Oops. Okay. Reach analysis. This pairs pattern match with constructors of the same size and uses them in place if possible. Huh? The list is updated in place without any extra allocation. Oh, okay. I see. So I guess what would have happened before is it would have allocated the first list and then the new list. But in this case, it can see that it's not. Okay. I mean, I prefer if dot maps always did it in place. And like if I wanted to copy, then I'll do it explicitly by saying like dot copy or dot clone. Functional but in place. So it is unique, yeah. This is the C++ implementation or what? Hold on. It's 7% C. Okay. So that'd be for like the low-level stuff, right? OS, int.h, ref, integer. Yeah. I assume this is also C code? Because I mean, here it says C++, but this looks to be valid C as well. But surely it is, because it uses function T. Okay. It's interesting, but I feel like you could also just like, you know, again, have like explicit copies, but maybe there's good reason for it. Red black tree, yeah. Oh, this whole example here. I think in Rust you need to like box all of these. Is that right? Which I guess is like, for me that's like the main well, one of the core differences I've noticed between like Rust and Haskell is that like for this kind of problem with like recursive tree stuff, in Rust you have to use you have to make it boxed, a box pointer. But in Haskell, you don't have to do that. which is interesting. It has drop functions, free functions, and duplicate functions, or dupe, or whatever dupe is meant to be. If unique t. Okay. Okay. Some optimizations here. Sure. Right, a Effekt and Koka. Here we go. Yeah. Okay. So there's the there's the name explanation as well. So function main, put 9 hello world. Yeah. That's funny. Function declarations use fun, but then anonymous ones use fn. It's kind of interesting. Yeah. See, this is like a drawback of this feature, being that I don't want people to have both options, you know? Like, if I have braces, I want them to be for single line statements only. Otherwise, you get stuff like this, which is just like really ugly. I mean, not ugly, but like, you give people two different options, which can lead to inconsistent code, not ugly. Although, personally, I do also find this ugly, in some cases. Oh, wait. These like defined, right? No. Never mind. That's kind of cool how, like, that's tor/main. Yeah. Some, like, docs. What's checks, by the way? What does that mean? I don't know. Like, is it like after being like going through the formatter or something? So like, I'm guessing this would be removed. Like this would remove the unnecessary braces here. Here's another short example program that encodes a string using the Caesar cipher, where each lowercase letter is in a string is replaced by the letter 3 places up in the alphabet. Okay. So you can have nested function declarations. Notice there's no like colon, by the way. Right now I use colons in like everything from like if statements to whatever. More so just so that you can easily make stuff inline, but I don't know. Maybe I'll change that. I mean, this has if then. The colon just means then, you know. That's the idea. Val. I believe this language is val and var and let, if I could be wrong. Oh. And it uses colon equals for mutation, but normal equals for not mutation. Which is weird to me. I prefer having have various has like the set keyword. I think that's like just a nicer way to do it. The spacing is funky. This one doesn't use it, but this one does for some reason. And there's return type, string. It does use colon. I'm guessing colon's also used for other types. Yeah, like string, shift, int, yeah. Hold on. What? Wait, what? Oh, S1, okay. Right. Dot syntax. S dot encode makes that S and shifts 3. Okay. Sure. Hopefully there are named function parameters, but I have a feeling there won't be. Dot int, by the way, to cast is interesting. Although I mean, I prefer like to int, but like this is, yeah, okay, why not? There's modulo. It does use symbols like or instead of like keyword or, so I'm not a fan of that. Dot selection. Yeah. I don't like dot syntax being syntactic sugar. Like I feel like dot syntax should imply ownership of functions, otherwise it can get quite messy. Like 3.add5, like. C.int. So like is int the a constructor here? And C is like .int is like calling the C, like the int constructor on C. Also weird. Like for like stuff like that, I prefer piping, but then even then piping is kind of unnecessary. Intuitive. Is intuitive spelled with a German I? Well, like originally. S1 code 3 is not count or print line. Again, like piping can do that, but okay. This is my issue where like you just write a new function that takes a type as its first argument, right? But like I prefer having like an explicit like extends syntax to extend the class, because then that's probably better for documentation, I feel. I don't like the good practice thing. Like, if it's good practice, why make the bad practice even like possible? By like making the type inference system too powerful, you know? Like maybe there are some cases where like you really need it to be powerful, but then like see if you can tackle those separately without compromising the general case. I don't know. Like, we think in trade-offs, you know, and say like, okay, so like this is a trade-off, so we'll just do this, whatever. But I feel like a lot of the time as well, we fail to consider or like there's like a mindset where like you understand that there need to be trade-offs, but then like you don't look for a solution where you can minimize trade-offs for some reason. Like that's just like something I've noticed where like people will hear, you know, like the general advice, you know, sometimes they make trade-offs, but then take that to mean, you know, the moment I need a trade-off, I'll just take it, as opposed to like trying to think more deeply about what else could I do. Of course, the trade-off there is, you know, how much thought and time do you dedicate to that syntax, or do you make the trade-off, the compromise of just going and skipping ahead, but whatever. Oh. So this is trading lambdas then. But like, is it explicitly, or is it a like consistent rule in the language about how indented blocks would mean braces, brace elision, right? For 110 print line, yeah, okay. If I were to support this, I'd probably still have like the... I don't know. I don't know actually. It's interesting. Ass suspenders, but it said twice. Okay. UFCS. Yeah. Dot notation. So Kojo was one of the first, huh? The with statement. I believe Swift has trailing lambdas actually. Trailing lambdas. With the ease of passing a function block as a parameter, these become nested. What? Twice, print line high. Prints 4 times, yeah? With statement does this. With twice, print line high. So with puts all statements that follow into an anonymous function block and passes that as a last parameter. Huh? So it's just a way to have this, but without the without the indentation, right? Okay. Sure. Yeah, sure, I guess. But it can also bind a variable parameter with ax. Why can't I just say with list 1 to 10 for each? And they say it's reminiscent of do notation in Haskell, but I don't see it. Because do is a quite different thing with monads, right? I don't know. I think with has more uses in like the effect system, as we saw, effect handling, as we saw above. But like just this alone is like weird. Like in this particular example, I don't mind the nesting. Like if anything, you should do twice dot repeat 2, you know? Instead, like have that kind of construct rather than like having with twice. But okay, I will see how else it's used throughout this language. With finally, also like sorry, I still don't get what the binding's for. Oh, function x over here. Okay. So like, I feel like this is just weirdly complicated. So it says for each x, print line x. I guess it's just very weird, you know. Very weird syntax. Okay, I see how the arrow can be reminiscent of Haskell do notation. To be fair, but like, what the hell? I don't even like Haskell do notation anyway. Like, I don't like using it because it feels like I'm kind of cheating in a way. Like, it makes you wonder why a language can't just have Haskell do notation like as a default. Okay. The finally function takes as its argument a function that is run when exiting the scope. So it's like defer. With finally print line exiting. That's also weird. I don't like how these functions are on verbs as well. Like, with defer would actually be a lot nicer, you know? But then you also don't get like the same kind of nicety as defer. Because defer can go anywhere in the function, right, usually. Whereas this has to go at the top level, right? And that's with statements can just go anywhere. Maybe they can. I assume so, actually, maybe. Let me find the online Kojo compiler again. Koka. So say I have function main, print line, whoops, print line, hello world, run that. What? Oh, what? Why does it require braces? Is this like a new thing? Like, is a brace legend a new feature? Okay. How about with finally print line done. Okay, doesn't seem to be very good. Okay, whatever. Hold on. So typically, it's useful with effect handlers, okay? So an effect describes an abstract set of operations whose concrete implementation can be dynamically bound by a handler. Here is an example of an effect handler for emitting messages. So I have an effect function emit. Okay. Is this how you do like abstract stuff in general, like interfaces? So you have emit a standard greeting. It's kind of confusing how it goes here, by the way, but okay. Emit hello world. With handler, function emit print line message. Hello. So handler desugars to, but all this is desugaring, it's quite confusing. Function emit message. Yeah. Function hello. And we can also leave out the handler keyword. What's TTL? Using this convenience, we can write the previous example in more concisely as this. Yeah. What's this though? Because these are two separate expressions that are next to each other. So how's that work? Optional name parameters. Supports both optional and named parameters, thank God. Replace all to the string pattern. So it takes a string, a name pattern, and a replacement string named REPL. Okay. Optionals look like this. Okay, pretty standard, I guess. Okay. Can you define custom operators? Because that'd be kind of interesting. Because like I'm against that, generally speaking. Sublist. It's a list of $2188, of course. Start and len. What? Like a sublist of... Oh right, this function, yeah. What's total sign 2188? Wonder how I got that number from. I mean, from this, obviously, but like... It doesn't really mean much to me as the human hovering over it. Right. So it's a question mark int. So like is that optional? Like is it actually optional like a maybe type? Because building in default arguments via optional is pretty interesting. And could be done. Right? Like, suppose this meant int was an optional int, and by default not including an optional type in a function list just makes it none. Generally, sorry. Yeah, whatever. Cracking Caesar encoding. Okay, so here's an example. Import standard number float 64. Okay. I have actually read this book. I forget if I read it from front to back. I might have. Okay. I've also like made this myself for a university assignment. This is just an example, is it? Can't help but feel like this example doesn't really show off the language all that well. Like there's no like with keyword or anything here, and there's like not a single effect in sight. But, you know, it's the basic syntax. So you got a list like this, small helper functions, return is implicit, okay, or can be. So I just realized it uses these braces for type arguments, or whatever you call it, like template parameters, or generic parameters, whatever, which is controversial. I wonder why don't you support the C arrow, like the double arrow syntax for anonymous lambdas. It's pretty cool. Like I don't love the fn keyword for anonymous functions, even though I use it right now, but. Okay. You can pass plus as an operator. That's cool. The val keyword declares a static value. In the example, the value English is a list of floating point numbers of type. Ooh, I like static and dynamic for value names. Usually I hear like immutable or mutable. But yeah, static is a cool name. Rather than that being const. Denoting the average frequency for each letter. The function frex. Okay. The interactive environment has examples built in. Effect types. It automatically infers effect types. Side effects. The absence of any effect is denoted as total, so by default it is total, which makes me wonder why you would ever want to make it explicit. I guess to say like only accepts total functions. That's a bit weird. What? Total or empty angular braces, and corresponds to pure mathematical functions. If a function can raise an exception, the effect is xexn. Okay. Again, I don't understand this whole exn and div is pure. Non-deterministic functions get the ndet effect. The worst is IO, and means that a program can raise exceptions, not terminate, be non-deterministic, read and write to the heap, and do any input-output operations. Right. I'm guessing that's because like reading and writing to the heap and doing like IO, just like intrinsically, is both non-deterministic, but can also raise exceptions, or cause like a crash that will not terminate. Anyway, so total, yeah, whatever. When the effect is total, we usually leave it out. Sometimes we write an effectful function, but are not interested in explicitly writing down its effect. In that case, we use a wildcard type. It's denoted by writing an identifier prefixed with an underscore, or an underscore by itself. Right. That means that means you're being lazy. Nah, that should definitely be explicit, because like otherwise it defeats the purpose of having effects. Like it helps the compiler as well, without having to rely on type inference or effect inference. So I'm not a fan of that. Okay. The inferred effects are not just considered as some extra type information or functions. On the contrary, through the inference of effects, Koka has a very strong connection to its denotational semantics. Sorry, denotational. In particular, the full type of a Koka function corresponds directly to the type signature of the mathematical function that describes its denotational semantics. For example, using T to translate a type T into its corresponding mathematical type signature, sure, we have this. So an int to total int is just z to z, right? Yeah, I don't know what this means. See, like, this is like the kind of stuff that I want to learn how to read. What's plus one? I assume plus is for some types, meaning or. What topic does this kind of notation fall under? Is this category theory or something? Just where z to z plus 1 means a morphism from the category of integers to either the category of integers, no, from an integer to either an integer or 1? Makes you wonder why. Set plus error. This is Koka, FYI. So, okay, set plus 1, pure int. Dude, I still don't get what pure is. Why is pure throwing an exception? I don't understand that at all. Pure functions in the Haskell sense are not. What is a pure Haskell function? Returns the same result for the same arguments. Yeah. So what's that got to do with exceptions? Also, why does Koka say that pure in the Haskell sense means both able to throw an exception and not terminate? I thought a pure function was just deterministic. Denotational semantics. And what does that fall under? It's a formal way to define computer languages by mapping expressions and programs directly to extract mathematical objects. Okay. It's like oddly specific. And we're back. Wait, and we're back. Okay. So this notation is a particular kind of notation. I didn't get an answer on like what it falls under, but whatever. So this means +1. It's probably like some kind of error thing, I guess. You know, it's an exception. And then you have this for, what was it? Yeah, that's it, diverges, which means it may not terminate, right? Like in the case of concurrent, of async things. So this means may just not return. Kind of weird notation for it, but I assume there are reasons. No idea why. I assume this is a product type, Z and H. But like here, there's no H in the signature, so what's that? What's STH? So ZH, Z times H to Z plus 1 times H. Yeah, don't understand that, but okay. In the above translation, we use 1 plus tau as a sum where we have either a unit 1, i.e. exception, or a type t. I'll say t for now. And we use h times t for a product, okay, so that's whatever, consisting of a pair, yeah, of a heap and a type. Heap. Right, from the above correspondence, we can immediately see that a total function is truly total. Okay, yeah, no crap. Well, a stateful function, oh, so ST for stateful, that can raise exceptions, or not terminate, pure, takes an implicit heap parameter, and either does not terminate, or returns an updated heap together with either a value or an exception. Very weird way of thinking about it, to be honest. We believe that this semantic correspondence is a true power of full effect types, and it enables effective equational reasoning about the code by a programmer. Right, so that's for like type systems and proof systems, I guess. For almost all other existing programming languages, even the most basic semantics immediately include complex effects like heap manipulation and divergence. In contrast, Koka allows a layered semantics where we can easily separate out nicely behaved parts which is essential for many domains. Life's sake, link queries, parallel tasks, tier splitting, and sandbox mobile code, etc. Often a function contains multiple effects. Yeah. The effect assigned to combined effects are, we can write such combinations as a row of effects. Right. When you hover over the combined effects identifiers, you will see that the type inferred is really pure and det, because pure is both of those. It's kind of funky how you have like compound effects like that. I'm not sure if I'm a fan of that. Especially calling it pure. Like, what's that really useful for? Because like throwing exceptions and diverging are two fairly different things. Unless it's more for like the type checker to say, oh yeah, it's pure, therefore this is fine. I don't know. Many functions are polymorphic in their effect. For example, the map function applies a function f to each element of a finite list. As such, the effect depends on the effect of f, and the type of map becomes fa to eb. Okay. I don't know what that means, by the way. Like, if it returns like an IO int, like, what does that actually mean? Like, is it wrapped? You use single letters. Possibly followed by digits. Okay, so they can be for polymorphic types. Here, the map function takes a list with elements of some type A, and a function f that takes an element of type A and returns a new element of type B. Personally, I prefer capital letters. The final result is a list with elements of type B. Moreover, the effect of the applied function E is also the effect of the map function itself. Indeed, this function has no other effect by itself since it doesn't diverge nor raises exceptions. Because like, I assume you can't have like an EB as input. It's just a return type. It's kind of weird, I don't know. You can use a notation left or E to extend an effect with another effect L. This is used, for example, in the while function, which is type while, predicate, diverges, or E bool, action. What? The while function takes a predicate function and an action to perform, both with effect div or E. Indeed, since while many diverge depending on the predicate, its effect must include divergence. A little side note, when you use notation like this, it's useful to kind of say how it's pronounced, right? Like L or E. But like, I'm not sure it is E. Is it just extends? Like, what does that mean? Indeed, since while may diverge, the reader may be worried that the type of while forces the predicate and action to have exactly the same effect, which even includes divergence. However, when effects are inferred at the call site, both the effects of predicate and action are extended automatically until they match. This ensures we take the union of the effects in the predicate and action. Oh, why is it a bar then? Take, for example, the following loop. While is odd, throw odd. Kojo infers that the predicate odd has effects non-deterministic E1, while the action has effect exception E2. For some E1 and E2, okay, when applying while, those effects are unified to the type these for some E3. What's E3 then? Is there a reason why it's bar, like ndet bar E1, and not just n or pipe whatever, and not a comma? I don't really understand that. I feel like I need to see more examples. The Fibonacci numbers are a sequence where each subsequent Fibonacci number is the sum of the previous two, where fib 0 equals 0, yeah. So if n doesn't equal to 0, then 0, elif, 1, else. Is it not pattern matching? Sure, there is. Diverges. Note that the type inference engine is currently not powerful enough to prove that this recursive function always terminates, which leads to the inclusion of the divergence effect div in the result type. Is it type inference if it's proving? Here's another version of the Fibonacci function, but this time implemented using local mutable variables. We use the repeat function to iterate n times. Yeah. I mean, yet another reason why recursion sucks, but... it's almost like mutation is useful. So you got var for variables. In contrast to the val declaration that binds a mutable value, as in val, a var declaration declares a mutable variable. Okay, and you have colon equals. Internally, the var declarations use a state effect handler, which ensures that the state has a proper semantics even if you're zooming multiple times. What does that mean? However, what does that mean? However, that also means that mutable local variables are not quite first class, and we cannot pass them as parameters to other functions. For example, you get a type error if a local variable escapes through a function expression. Right. So you kind of like closures like that. This restriction allows for clean semantics, but also for future optimizations that are not possible for general mutable reference code cells. Okay. But I assume I can pass it in here, right? As a function argument. But can I mutate a variable through a function argument? Can I do that? Because I mean, like, what's the alternative? I could just use in place and hope that it compiles, that it optimizes. Not a fan of that. If that's the case. Yeah, this is just really weird to me. It can't prove that it's terminates. Why not? Oh, because like it can't track the base case. No, but that's fair. Because like there's a non-zero chance I pass in like a negative number. Like that's totally possible in that case. So like this function, not only is it a failure of the type inference system, or like, I mean, it's not even really a failure of the type inference system. It's more just that n can be negative, therefore this could easily go on forever. Like that's just what happens. Wait, no, but it says less than or equal. It says less than or equal to. I wonder if there's a way that you can rewrite this such that it can be checked. Where are we? A tour of Koka. Effect types. Don't know, I'm switch to Japanese then. Effect types. Local mutable variables. Yeah, so considering this code here, I wonder if this code, if this recursive code or function could be written in such a way that the compiler is able to prove that it does not diverge. Because like we as humans definitely can. So why can't the compiler? Like what? Like I assume it's a syntax issue, right? My assumption is that if a human can infer it, or if a human has enough information to prove it, then the compiler can, as long as it is able to parse the syntax. Well, like, as long as it is able to understand from the syntax. sorry, as long as it has the right syntax, as it is fed. So like, so something like a recurse statement, even like recurse with base equals 0, or like, I don't know. For numbers is one thing, right? But for like strings and stuff, I mean, my guess is that in the context of strings, like there is a non-zero chance that it diverges or whatever, it doesn't terminate. But for a case like this, like as long as you can say, well, if it's 1, it's 1. If it's less than or equal to 0, it's 0. Otherwise, it's fib n minus 1. And because it's minus 1, then it's always decreasing, right? Like that's what we say. If it's minus 1 or minus 2, that means n is decreasing, and therefore it'll reach the base case. Like why is this not provable? I don't understand. Can someone explain why this isn't provably terminating? It's an example from Koka. And the function has to be marked with the div non-terminating effect, since the type inference system cannot prove that this will eventually terminate. Like for this example, come the compiler see that minus 1, that n minus 1, n minus 2 means that n will always decrease, and thus eventually structural recursion. Yeah. So like I assume it's possible. What is dependently typed? But even then, I feel like this is provable for the compiler. All it really needs to do is observe that the function is being recursively called with n minus 1 and n minus 2, meaning that n can only decrease, meaning that it will at most get as far as the n less than or equal to 0 condition, and thus terminate. You know? Where types can depend on values. Effect NT of list T with no length n, where n can be a runtime value. Right. Okay. What's that got to do with this function? Okay. Yeah, why can't n be a runtime value, by the way? I guess because I can't reason about it, but like it could reason about it. Also, what dependently typed languages are there? That sounds like something I'd like. Okay. Reference cells. So there's more on this somewhere else. Guess we'll see. Reference cells and isolated state. Kojo has first class heap allocated between reference cells, right? Like boxes, I guess. A reference to an integer is allocated using val r equals ref 0. Right. Yeah. Okay. Since the reference itself is actually a value. Is it a pointer? I don't understand. It is a pointer. Except it's a reference, not a pointer. So I guess it can't be a null reference. We can write the Fibonacci. Yeah, do you need... Like Jordan Peterson. Do you need pointers in a language? Like a system language? Or can you just get by with just having references? So then you get return to reference instead. And then to have a null reference, you just use option. Right? Because I mean, then it's safer, because then like you can't dereference a null pointer. And it also means that you don't need to have 0 be null either. Like there are some systems where you would genuinely want to dereference a null pointer to get to that memory location. If we just use option instead, that wouldn't matter. It would have some overhead though in terms of, I guess, like the size, and it's probably optimal for, at least for most platforms, where 0 is guaranteed to not be addressable. To just have that kind of sugar to that, but like, that's fine, like at least semantically, having it be 0. So this is fine. Exclamation mark though is kind of weird. As you can see, using verticalations are generally preferred as these behave better under multiple presumptions, but also are syntactically. Sorry, how's this being mutated? It's a static reference, but the memory it's at is mutable. As they do not need a dereferencing operator. Nevertheless, we still need reference cells as those are first class, while var variables cannot be passed to other functions. Right, so you pass references, not variables. That makes sense, I guess. Okay. So can I have immutable references? When we look at the types inferred for the references, we see that x and y of type ref h int. Do we? I mean, it's ref underscore 3678, whatever that means. Yeah, no, I don't see that at all, but okay. Which stands for a reference to a mutable value of type int in some heap h. Okay, fine. So that's the heap ID. The effects on heaps are allocation as heap h, reading from a heap as read h. The effects on heaps are allocation, reading, and writing. The combination of these effects is called stateful and denoted with the alias st. Right, so if a function writes to the heap, it uses write with the address. Okay, this is cool, because in verse, they also have a read and write, and I think also like it allocates, but it doesn't tell you like which heap it is, or like which address it is. Wait, what's this reading from a heap? These are on the same heap, right? Okay, so like it still doesn't tell you like which heap variables are being read from and written to. Cause like I don't like having just like write h, you know, like I wanna know which variables specifically are being written to, because that's more flexible. But okay. Rock you lean Agda address. Okay. Why don't more languages take advantage of dependent typing then? What's the cost? Clearly the effect of the body of fib3 is STH. But when we hover over, is that because it only mutates stuff inside itself? Indeed, even though fib3 is safely inside, its side effects can never be observed. It turns out that we can safely discard the effect whenever the heap type cannot be referenced outside this function. So 0 and 1 will allocate, right? See, that's a bit confusing because ref, therefore, I assume, can both allocate and also just take a reference. So that sounds a bit confusing. More formally, the Koka compiler proves this by showing that a function is fully polymorphic in the heap type h and applies the run function to discard the effect. What? The Garcia-Wax algorithm is a nice example where side effects are used internally across function definitions and data structures, but where the final algorithm itself behaves like a pure function. Okay? I assume that's completely fine. So just looking at the table of contents here. Right. Also, how do you have multiple heaps? Like, are they actually different heaps, or are they just like different heap accesses? It says reference cells. I don't know. This is reference cells in isolated state. Okay. So I like not having raw pointers and instead only having references, as it means null references must be represented through an option T reference, and therefore null pointer dereferencing is impossible. Under the hood, a compiler could still optimize this as a raw pointer with 0 equals null pointer on systems where that is indeed the trusted convention, or like indeed the rule even. An example in Lean was the array bool. Each bool is allocated on the heap. And stuff like this is hard to avoid because the dependent types make it a lot more difficult for the compiler to know stuff about the types. Yeah? Why would array bool be dependently typed? I don't understand that. Why would array bool be dependently typed if its type is known at compile time? Let alone why it would be necessary to heap allocate the booleans, the bools. Like, is Lean a language that is Lean a language that only exists at compile time? Okay. It's like, what about stack variables? Because ref heap allocates, right? Like, specifically on the heap. So how do I mutate a variable that's not on the heap, like just from like a function on the stack? Like, does that mean I have to heap allocate it next? Because that's just dumb, because like it's in scope. I mean, the compiler could optimize it, sure, but then like the actual semantics of the language are just wrong. Like if you want to go as low level as like having a heap, then you can't have it not be a heap, you know? Data types and struct. Okay, so structs. An important aspect. Okay, that's actually quite interesting. I wonder how I'll do this. Is to be able to define which data types over which the functions work. A common data type that is of a struct or record. Is that of a struct or record? Is a record another thing in this language, or is it just structs? Like as a keyword. Here's an example of a struct that contains information about a person. So age, name, and real name. Interesting here, how you can do that. So val Brian, yep. Every struct and other data types come with constructor functions to create instances. And they have named arguments as well. It's just functions all the way down. Good. Yeah, mostly about not having special rules. Because like, just have them both have the same rules, and then like they all benefit from each other. Also, Koka automatically generates accessor functions for each field in a struct. Right, so Brian.age is a function. And you can also just call age Brian. Issue is then, is that global scoped? I assume not, right? Because like that's kind of important. And that's like one reason why I don't like the whole like dot syntax thing, because like it doesn't really, like it kind of falls apart there. Compile time interpreter. This particular example is probably avoidable, but in general array T could have T be something very different. So I'm guessing this is a particular case where array T is assigned bool. Dynamically. Yeah, compile time interpreter, it would be slower, right? Does it have to be though? Like, if it's just... check N, check that, step through. I mean, not necessarily. Right. But surely recursion can be checked more simply. Jump to where the recursive calls actually are, and then check those conditions. Maybe with a special syntax for recursive calls, for recursive functions, that make it easier for the compiler to extract the information it needs. It says special. I mean, like, dedicated. No idea how Koka termination checker works, but I assume it checks for primitive recursion. If so, and if Koka has natural number type, use those instead of integers should work. For what it's worth, Koka termination checking is particularly smart because it doesn't really need to be. What does that mean? I'm not really sure why this is such a common perception. As far as I can tell, dependency doesn't have any particular issue with defining the sizes of every type. You just need evidence of the value size when you allocate. It might not be known in various contexts, the name of the type, but we only need that concrete info when accessing the value. So for algorithms with a complicated measure, what do you do in Koka? Just say it might not terminate? Yeah. Or unsafe assert. It's fair, but it's annoying. You know? It doesn't matter that much in the grand scheme of things. Right. Just a smell of the language. The nice thing is that most recursive functions can be written bottom up instead, and those wouldn't, and those would be provably or at least yeah, on this, by the way, it is mostly the sizes, right? It's the size of the type that really matters. Because, like, how you read the type can be done at compile time, you know? But, like, it's just, like, does it fit? So that when I allocate, I know how much I'm allocating. That's the most important thing. And even then, though, like, well, yeah, because, like, you need to know what the offsets will be beforehand. You could calculate them at compile time, but at runtime, I assume, but it'd be a lot slower, and probably require some kind of runtime anyway. So it'd be a bit slower. Just yeah, well yeah, It'd be slower. Whereas if you can statically check the types, like compile time, the sizes, sorry, then that's fine. Alright. Copying. Sorry, no, about this. Yeah, like age, Brian. I do find the idea of having functions with no arguments just being cool like variables. Issue is there is a difference between values and functions, and the distinction matters. Like, a variable is addressable for starters, whereas a function result is not. So that's already an important distinction. So having them look the same is like kind of problematic if you want to come, well, from like a low level perspective, where you'd want to have references and stuff. Like, I can't take the address of tail of like a linked list if tail is like a function that returns some like internal tail. Like, I can't. Well, to be fair, if it returns the variable, then I can address that. But I mean, like, let's say like it returns, I don't know. Okay, bad example. Like, let's say I have a function that just returns a value instead, a non-addressable value. Like, I can't address it. Copying. By default, all structs are immutable. By default. Instead of directly imitating a field in the struct, we usually return a new struct where the fields are updated. Yeah, Rust does that too. I'm not a fan of it. For example, here's a birthday function that increments the age field. I imagine it's easier for the compiler to reason about. But like, you are creating a copy, you know. Here, birthday returns a fresh person, which is equal to p, with the age incremented. The syntax p dot is a syntactic sugar for calling the copy constructor of a person. What? How is this syntactic sugar? Oh, because like it's on P specifically. I see. That's weird. This constructor is also automatically generated for each data type and is internally generated as that. When arguments follow data value, as in this, it is expanded to call this copy function, as in p.copy. I prefer just p.copy, honestly. Like, again, like, we're making copying feel really implicit here. Moving by default should always be the case, but I don't know if this language has like move semantics because of how it does reference counting. In adherence with the min-gen principle, there are no special rules for record updates. Okay. Yeah, I'm not a fan of that. Alternatives or unions? Alternatives. So you got ADTs where there are multiple alternatives. There's enumeration. Yeah, so that's an enum. Special cases of these enumerated types are the void type, which has no alternatives, and therefore there exists no value with this type. There exists no value with this type. What? The unit type unit, which has just one constructor unit. And finally, the Boolean type bool with two constructors true and false. What? I see, so that's how it's defined. As a shorthand, we can also write this for the unit type and this for the unit constructor. Yeah. So you got type void, type unit, which means nothing, and type bool. What is void for? When like in language we have units. What is void? Like in Haskell, a unit function is a void function. Like print line returns unit. Because like it needs to return some kind of value, right? Constructors can have parameters. For example, here is how to create a number type, which is either an integer or the infinity value. Yeah, we can create such number by writing integer 1 or infinity. Moreover, data types can be polymorphic and recursive. Yeah. They generate accessor functions for each named parameter. For list, for example, we can access the head of a list as cons 1 nil.head. We can now also say that struct types are just syntactic sugar for a regular type with a single constructor of the same name as the type. What? What's a type? What's a regular type? It didn't show that, did it? Oh, it's an enum. Okay. That's weird. But yeah, so a structure is just a type with one parameter. Yeah, I find this interesting, and I want to see how I can leverage this. Because like this is tagged, but this is untagged, so like it's just kind of convenient. Like tags are a whole other thing. They're quite weird. For example, our earlier person struct is defined as struct person. This equals to type person. Brace elision. It's kind of weird that it even uses braces in the first place. Is this a function? Is it? Like, can I have other statements in here? And have that basically be the constructor? Because that'd be pretty interesting, to be fair. Matching to do. Really? And EDT is also to do. There's no pattern matching then. Oh yeah, it would be interesting if a type's members were defined in a like we're taken from a function call. Would it though? I mean, like, would it be good though? So like the type body is just a function where every definition, yeah, where every definition is just public to the person calling the type. It's kind of weird, isn't it? It's a weird idea. And it doesn't handle multiple constructors either. Yeah, I don't know how that would work. Okay, inductive, co-inductive, and recursive types. For the purposes of equational reasoning and termination checking, a type declaration is limited to finite inductive types. There are two more declarations, namely co-type and div type. Okay, that allow for co-inductive types. and arbitrary recursive types respectively. See, I don't know what any of that means. Recursive types, arbitrary. So I'd like to understand this by reading those books. Value types are non-recursive data types that are not heap allocated, but passed on the stack as a value. So you prefix it with value. Since data types are immutable, semantically these types are equivalent, but value types can be more efficient as they avoid heap allocation and reference counting, or more expensive as they need copying instead of sharing a reference. What? Why would it be heap allocated anyway? Like, surely I should just have the ability to heap allocate it when I want to heap allocate it? Like, I don't like it being built into the actual type, because sometimes I do want to heap allocate it, and sometimes I don't. Sometimes I just want to use it on the stack, you know? So why is that a thing? Like a vector, I mean, even like in C++, like a vector isn't like heap allocated. It's stack allocated, it just does heap allocation for its data. And that's why there's no explicit like new. The only time you call new is when you are making a type that for some reason can't be wrapped in standard library types, and therefore you do new manually, and that's fine. So yeah, I'm not a fan of this at all. Although I'm aware it probably is necessary for the reference counting system. It's just kind of weird, you know. There's no need for it. By default, any non-recursive inductive data type of a size up to 3 machine words is treated. Why would you say 3 words, bro? Is treated as a value type. For example, tuples and 3 tuples are passed and returned by value. There are tuples in this language. Usually that means that such tuples are, for example, written in registers when compiling with optimization. Okay, I don't really care about the implementation details, unless you tell me it's slow. We can also force a type to be compiled as a value type by using the value keyword in front of a type or struct declaration. What? I don't understand these, man. Like, these languages are just so... Like, I don't understand how people can code in them. Like, are they not really annoying? And the compilers working overtime just to try and optimize things that are only like that because of how the language is designed. It's kind of shocking. I mean, Rust has been around for a while now. I hope that it would inspire more languages to go oh yeah, we don't actually need to have some abstraction over heap allocation, so that heap allocation is impossible unless you do it in some really roundabout way. To support genetic polymorphism, sometimes value types are boxed. For example, a list is polymorphic in its elements. That means that if you construct a list of tuples, that the element 1, 2 will be boxed and heap allocated. What? A list is polymorphic in its elements. Therefore, what? Are tuples not also polymorphic? How's a tuple any more polymorphic than a list? I assume arrays are different than lists, but are they? Note that for regular data types, an insboxing is free as an isomorphic. Moreover, value types up to 63 bits are boxed in place and do not require heap allocation. Right, so it's like the Java optimization. The float64 type is also specialized. Wait, so int64 is heap allocated. I just don't get it. I don't understand why you would... make the language suffer in this way. Flow 64s can also be heap allocated. Sorry, stack allocated. When the absolute value is outside the range. How does it know that though? For performance-sensitive code, we may specialize certain polymorphic data types to reduce allocations due to boxing. What? It's more efficient as it needs only one allocation for the mycons without an indirection to a tuple. In the future, we hope to extend Koka to perform specialization automatically or by using special directives. Oh my god, dude! I like every time I look at one of these like research languages and the way just look at the way they handle memory management. It's so bad. Like it's actually so bad. Why does it need to be this way? Like I think Rust has proven that it doesn't need to be this way. Like, does this language do anything particularly special that would like where that's even like warranted, or is it just a matter of like not wanting to design it better, you know, which is like fine, but then, you know, if you're not gonna try to make the language nicer, you know, just better, full stop, then I'm not going to use it. Effect handlers are a novel way to define control flow abstractions and dynamic binding as user-defined handlers. These references? Yeah, I think those are papers at the bottom. No need anymore to add special compiler extensions for exceptions, iterators, async await, probabilistic, blah blah blah. Moreover, these handlers can also be composed freely, so the interaction between them, say async await, and exceptions are well defined. Okay, let's start defining an exception effect of our own. The effect declaration defines a new type together with operations. Right, so I've kind of had like a bit of yesterday I had a bit of an introduction to this, but I didn't understand it. But I was asking some questions about it. The effect declaration defines a new type together with operations. For now, we use the most general control operation. So control raise. So it's like an interface. This defines an effect type raise together with an operation raise. Don't like how they have the same name of type, yeah. With the effect signature declared, we can already use operations. So safe divide, but we need to define it, right? If y equals 0, then raise div by 0, else x over y. Where we see that the safe divide function gets the raise effect. Yeah. Such an effect type means that we can only evaluate the function in a context where raise is handled. Right. So it forces you to handle it, basically. I mean, I feel like result types are the same thing, but such an effect type means that we can only evaluate the function in a context, yeah, okay. We can handle the effect by giving a concrete definition for the raise operation. For example, we may always return a default value, 42. So that's 50. No. It yields. Why does it yield? it will yield to its innermost handler, unwind the stack, and only then evaluate the operation definition. In this case, just directly returning 42 from the point where the handler is defined. Why? Is that true just in general then? It will yield the value? But what if I want to, I don't know, I guess propagation would just be raise it again. Like CTL raise equals raise or something. I don't know. Now you can see why it is called a control operation, as raise changes the regular linear control flow and yields right back to its innermost handler from the original call site. Also note that raise const is total again. Yeah, the handler expression is a function that itself expects a function argument of which the handler is scoped, as in handler. This works well in combination with the with statement, of course, as to syntactic convenience. For single operations, you can leave it with the handler keyword, yeah. We have a similar syntactic convenience for effects, with one operation where the name of the effect and operation are the same. We can define such an effect by declaring its operation, which immediately declares an effect type of the same name. I don't like that though, but sure, fine. So an effect raise. Okay, sure. Resuming. The power of effect handlers is not just that we can yield, but we can also resume back to the call site with the result. Let's define an ask A effect that allows us to get a contextual value of type A. So effects ask why does it have to be ask A? Effect A CTL ask. They're like why A? Because here we have raise. And this returns an A as well, but that isn't there, but here it is. And then add twice, we'll just do ask plus ask. Ask int. Yeah, like why is it ask int and not just ask int? I guess because like it asks for an int. Well, so like the type isn't inferred then? I don't understand that syntax. The add twice function can ask for numbers, but it is unaware of how these are provided. The effect signature just specifies a contextual API. We can handle it by always assuming with a constant, for example. Resume 21. Wait, so what does resume do? There's yield and resume. No, but yield is automatic as well. Resume will do what? Just return it? Function is implicitly bound by a CTL operation and resumes back to the call site with the given result. As we saw in the exception example, we do not need to call resume and can also directly return into our handler scope. For example, we may only want to handle ask once, but after that give up. What? I thought you couldn't mutate variables from within a function. But here we are. Am I tripping? What? Yeah, here. Like, you can't do this. But for some reason, I can do this? What? With this synthetic sugar, we can write our earlier as const example using a fun operation instead. With fun ask 21. Okay. This also conveys better that even though ask is dynamically bounded, it behaves just like a regular function without changing the control flow. I guess? Kinda weird though. Moreover, operations decoded as fun are much more efficient than general CTL operations. The Koka compiler uses linearized evidence passing to pass down handle information to each call site. What? More efficient? What's an evidence vector, bro? Right, so it's an optimization, yeah, okay. So that's so silly though, how like it has to be optimized, just to not be absolutely terrible. Huh? Okay. So many ways to like squeeze out performance, dude. Like, man, how about you just make it performance like be the default? I don't know. By like, designing the language in a different way. Such effects are statically guaranteed to never use a general control operation and never needs a capture or resumption. Section 3.4.12. See that later then. During compilation, this removes the need for the monadic transformation and improves performance of any effect played by a function that uses such effects as well. So st state is linear, and IO console also state linear. Sorry. What? There's also val. What? Liner truncate 40. What? There's a width effect? I mean, this whole issue is solved through having objects and classes that can contain functions. This is such a weird way to do this. Having width as an effect, like, that isn't semantic at all. I have a width effect. The width capability. What? Nah. I mean, it's a research language, but yeah, just I don't like that. Like, the research shows that this is not a good idea. As another example, a write-to effect is quite common where values are collected by a handler. For example, you can define an emit effect to emit messages. Yeah. Yeah. emit as an effect. Like, you don't need to do that. Like, just pass in functions, right? Like, effect handler can be a function you pass to the object. Where make console is has the infer type this, okay. However, the source is the infer types, where the action can have where the action can have use the effects, emit console and any other effects E, and where the final effect is just console E. Now we could have written the above two as sure. Since the handler expression is a function itself, generally we prefer the earlier definition though, as it allows further parameters like initial state. Okay. Oh my god, dude! Like, imagine having to like memorize these rules and like, yeah, but in this case, I actually shouldn't do the synthetic sugar because that would be confusing and be less flexible. It's like, well, it'd be nice if the languages had this kind of sorted. Since works generally, we can use the abstracted handlers just like regular handlers, and our early example can be written as this. Right. As another example, consider a generic catch handler that applies a handling function when raised is called on our exception example. Like try and catch. Yeah. We can now use it conveniently with a with statement to handle exceptional situations. Yeah. So handler function can itself raise as well. Okay. What are everything structures do? I don't know. I'm missing some theory for that. It's a return operation? Okay. So state effect, set and get. What? Get and set? Function sum down. Val I equals get. If I less than equals 0, then sum, else set I minus 1, sum down, sum plus 1. So cursive. We can define a generic state handler most easily by using var declarations. Function get st set st Yo, what? Is this built in or is this ours? I don't understand that. Why do I have getters and setters, dude? I don't understand. Just get. But get what? That variable, but then I have to like define like that instead of like specifying which one. Okay, I don't understand how that's useful. Building on the previous example, suppose we also like to return the final state. A nice way to do this is use return. And it's even possible to have a handler that only contains a single return. Combining handlers. What makes effect handlers a good control flow abstraction? There are three fundamental advantages, okay, with regard to other approaches. So they can have simple, hindly minimal types, whatever that is. This, unlike shift reset, for example, this is unlike shift reset, for example, as that needs type rules with answer types, as the type of shift depends on the context of its matching reset. Don't know what that example is. The scope of an effect handler is delimited by the handler definition. Just like shift reset, but unlike call CC, don't know what that is, delimiting the scope of a resumption has various good properties. Right, I mean it says advanced here. Like efficient implementation strategies, but also that allows for modular composition. And they can be composed freely. By the way, it said that this language to like draw some category theory, but it hasn't really like referenced any things yet, to my knowledge. The Koka compiler internally uses monads and shift reset to compile effect handlers though, and it compiles handlers into an internal free monad based on multi-prompt delimited control. By inlining the monadic bind, we are able to generate efficient seed code that only allocates continuations in the case. Okay, I saw that as well. A great property of effect handlers is that they can be freely composed together. For example, suppose you have a function that calls raise if the state is an odd number. Then we can compose a p state and raise maybe handler together to handle the effects. Yeah? Where both the state and raise effect are discharged by their respective handlers. Okay, sure. Note the type reflects that we always return a pair. Okay. However, if we combine the handlers in the opposite order, we get a form of transactional state, where we get either an exception, or we get a pair of the result with the final state. Yeah. Kind of funky how that works. It's almost like you want the nesting in that case. Masking effects. Similar to masking signals in Unix, we can mask effects to not be handled by their innermost effect handler. The expression mask modularly masks any effect operations in F inside the action. I don't know what Unix masking signals even are, because I don't Doom operating system design? Like, why is this assuming that I know that? The expression mask modularly masks any effect operations. So like it kind of breaks out. Sure? Really weird syntax, dude. Like it's interesting what it's trying to do. Like I don't like what is exploring, but this is so weird to use. The second call to emit is mask, and therefore it skips the inverse handler. The type of mask for some effects label is that and where it injects the L, even though it's never blah, 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 blah. This type usually leads to duplicate effects labels. For example, the effect of mask is emit. So there needs to be two handlers. Right. In this case, when I skip over, yeah, effect abstraction. Generally, we can use mask to hide internal effect handling from higher order functions. For example, consider the following function that needs to handle internal exceptions. Right. Here, the type of mask print does not expose at all, that we handle the raise effect internally for a specific code, and it's fully abstract. Even if the action itself would call raise, it would neatly skip the internal handler due to the mask raise expression. Okay. If you would leave out the mask and call action directly, then the inferred type of action would be, okay, stay as a combined effect. Peek and poke. What? Oh my days, this is so complicated. Hold on. So I'm trying to figure out, because the idea of effects seems interesting to me, not just for mostly for documentation purposes, not just for the human reading the code, although it is useful for them too, but also for the compiler, so that the compiler doesn't have to, check a bunch of things every time it goes down a call graph or whatever. It can just know, because when I created the function, the compiler had to first, check that one time, and then it becomes part of the signature, right? Which is cool, but like effect handlers, I don't really see the point of an effect handler. Like, is it even like a concrete example of an effect handler in real life? Right? Like it's as this guy said, it's about context, right? It's like providing context that this thing is in scope almost. Like this thing exists. But it's like, well, that's what objects do, first of all. So is this like a way to have OOP without objects? But like, objects having functions is not even like that bad. Like think of like category theory. You could probably have an object that contains, if I even think about this right, but like that contains morphisms, right? Like a category of morphisms, or a category of objects and morphisms. Like why is it not okay? Like the main idea is that classes just pass this, right, as an implicit argument, and then like that's it really. Like that's the main idea of objects. Like they do work in like a category theory, whatever, functional world. It's just like some syntactic sugar, you know? The original theoretical concept of algebraic effects, which no currently existing language implements, okay, is for composable semantics similarly. No, that's the end of the statement. Nice composable semantics. Similarly, we can use this on a basic level to define async, exceptions, etc. inside a library, getting the composition for free. Only the next level above is allowing a library to use it to add their own effects and handlers. Right. 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 Issue there is that had equations the program needs to follow. Okay. My issues are like, I feel like async, error handling, that kind of thing, should be on a language level anyway. Right? Like it should be something that like the language defines in the compiler. Hard defines. Right, so it's having them compose. Right. Right handlers. Almost like inheritance, isn't it? Mask behind. Okay. I guess that's to do. Side effect isolation. can invoke resume more than once. I wonder why you would do that. Choice? That's so weird. It's like this doesn't have an XOR with P and Q be passed from an outside source, right? I guess there is a difference there with OOP in that OOP only has this as the first parameter, whereas in this case, all you need are P and Q, right? But in that case, you would pass P and Q as parameters, surely. Like just parameters in the function argument. Initially and finally. Okay. So now file read is in effect. I just realized it supports dashes for names. It's kind of weird. Because it doesn't seem to use it very sparingly. Like you've got H close here, H read line, but we don't have dashes there. Okay. When people write documentation like this, do they ever like feel the weight of their habits kind of catch up with them? Like, do they ever stop and realize, you know, maybe F handle, F open, H read line, and H close, maybe those aren't the most, you know, easy to understand names. Like having with file with a dash and these having a dash, you know, maybe that is a bit weird. And having H just be like just a letter, even though usually single letters would signify type parameters. You know, like, do people ever think about that? Like EXN for exception? Why is it even EXN? I don't like, I don't know, EXC or something? I guess it ends with N, right? Exen, exception. To do, bro. Okay. There are a bunch of syntax things here. I wonder if this is like someone's PhD or something. Yeah. Okay. Right. strange. I want to hear, like, if this was the original motivation, I want to know more about that then. And how that, and what we can learn from that. Promises. Okay. Try catch. Yes, but if the throw happens in a promise, it must have been weighted with the await syntax, and resolve must have not been called before the throw. Well, I don't know JavaScript though. Okay. Do people still use promises? What is catch.js anyway? Or is this relevant to that, or more just like a general thing? Okay, I'm told effect handling in programming languages was originally designed to write different features like async, returns, and mutation. I could synergize all together, and I get in each other's way, and let's say / compose all together. But I don't really understand. There was an example from JavaScript of where that's an issue, but I don't know enough JavaScript to really understand. Uh-huh. Okay. Yeah, I'm not sure effect is much different, to be fair. I mean, it has different lambda syntax and has pattern matching, so I guess it's better in that sense, but it's also a playground, as a proper language tour, like, thing that isn't just one page. If you run these, maybe effect would have been a better language to look at first, to be fair. Hilariously, it's not gonna run. Not gonna run. Okay, it did really slowly. Huh. So put line must return unit then. What? Define main equals. Okay. I'm gonna look past the syntax because, like, whatever. At this point, I care more about the features because I know that syntax is gonna be pretty abysmal in most of these languages anyway. What? Is that triplet equals or is that me? Like the Greek letter, or is it C? So this is an effect, okay? It's interface exception. So it doesn't use the effect keyword, which really makes more sense to me, because to me an effect just looks like an interface. We declare the effect signature as an interface, like those are objects implement, yeah. While calling the method on an object would require us to know the receiver. Every operation can also be used as an effect by omitting the receiver and using do. Using throw as an effect operation means that we do not know, and maybe don't care, who the receiver and thus implementer is. We simply express how we want to throw and leave it to the context to decide what to do. Okay. Having a look at effect now, it already looks quite a bit nicer. I like how it uses interface over effect, for instance, and draws the connection, and notes the connection between effects and OOP handlers. Right. See, this is already making more sense now, which just makes it easier to read. Right. Wait, so if I have other classes? They're objects. So can I implement an interface? The return type of non-recursive functions can be left out and is inferred. In our example, it is double exception, that is, return type double is followed by a slash and the effects. So slash is the effects. Okay, I like that too, how it actually separates the effects. I also like how it separates effects with t/e rather than Koka's et. Each handler consists of a try block followed by one or more handlers. Oh. Wait, so try is just like a universal thing? So it looks a lot like exceptions, except you don't have to use them for exceptions, I guess. What else would you use them for? I'm trying to think. Like effects. Like, would you have like an async effect? Like, try this with yield? Or have like, I don't know. Like, I feel like this is mostly useful just for exceptions. I haven't used much async, so I can't really say, unfortunately. Not resuming is how you abort. There's panic. So this is non-resumptive. So resumptive means it resumes. Okay. Besides exceptions, we can also emulate other useful mechanisms with effects. For example, a generator function using the yield effect. I don't know what a generator is. When invoking the yield operation, we pass a value to be yielded to the lexically nearest handler. Lexically? What do you mean lexically? Okay. Like when you have a series of with statements or something, we call our functions from earlier. We may also write it as a generator that runs infinitely while yielding each Fibonacci number in the process. That's cool, actually. That means that you can implement lazy semantics via yielding, right? Oh my god. Lazy evaluation via yield. Honestly, quite incredible. Okay, let me make a new post here. So that was Koka. Not too much to say, but we'll look at this as well, which is effects language. Language tort. Authors are now published, today's date I guess, 13/08/2026. Tags, book, and link. Sator. Gay, locate that, there we go. So we've got effects. So first of all, with non-resumptive effects, resumptive effects. It's interesting. Okay, well, it's rather interesting how, unlike Koka, how effects are actually defined via the interface keyword, unlike Koka, which let me link to that. Koka, yeah, is it Y? Yeah, Koka. Which uses effect. I already felt that it was strange. I felt that effect definitions very much resembled interface declarations. Kind of. Does this mean that interfaces can also be implemented by classes / objects? Since do can be used on functions that could otherwise have an explicit handler. And then for resumptive effects, yield A, okay, yeah, I mean, already I just love, I like this syntax way more, dude, Jesus. I mean, not syntax, but like, well, yeah, I do. Like having yield capital and then this one lowercase, wah, having this here with like the explicit A, because you use A here, wah, they're capitalized, also unit, A is also capitalized, even though it's a single letter, it uses these instead of the angular brackets, wah. Effects are separate, like it's just great already. A lot more easier to process as someone who's looking into this for the first time, like effect systems. But yeah, this is crazy. So define inner function, do yield A, inner B, A plus B, inner 0, 1. And it is recursive, but like there's no effect here that says it may not return, because it's literally yields. So like that makes sense. Oh, that's so nice. So genfibs, try fib with yield, which is define yield x, yeah, equals. Yeah, oh my god, that's actually so much nicer. That's like insane. How much nicer that is, dude. What the heck? What is Koka doing, bro? Like, not a dog in a research language, but god damn, this is just so much clearer. Yeah, so if count is a limit, then fibs resume. Yeah. Something back to me? Yeah. It's honestly quite amazing that one can lazily implement, or implement a lazily evaluating version of a Fibonacci function via yield, via a yield effect. This makes perfect sense, and I do not know why I have not come across this before. Damn. Look at that. Genfibs 15, dot for each, x print line. Holy, holy lighting on that. Is there dark mode for this? Nope. Man. Oh, hold on. It is XE. Effect XE. Like the thing I pointed out, right? That comment with the 3 lines. But why? What does that mean? Effect? I mean, it looks like an E, right? If you squint hard enough. But I wonder why that's a symbol. Okay, this looks a lot more interesting then. So we got trilling lambdas, we got function syntax like this, which again just nicer. Resume. So sorry, let me try to actually understand this. So you have fib. I'm guessing, yeah, so resume must be built in to the language. But we have yield, which is defined under this. It's interesting, right? So you could alternatively do this, right? By defining an object that derives from yield. So like, create an object called like yield int, you know, call it like, make it anonymous, right? And then call fib on that. It's kind of awesome, isn't it? So looking at this example, this could be written via OOP. So like let's say we have, is there effect highlighting perchance? No. So we'll go with like, I don't know, what's good actually? Python? Whatever works. So we could have, yeah, so like instead of doing try fib, hold on, we call fib global function, it yields int, right? Yeah. Right, so you define the different effects for each one. I see. That's fine then, because like you can just derive from different things. So we'll have like, I mean, I'm not saying that this is better, but like I'm just saying you could rewrite it using objects by saying having a type deriving yield int, right, and then have define yield x equals, yeah, like whatever, blah, close that, and dot fib. Yeah, I thought Python would be good for this, but whatever. Yeah, that's kind of wild. Interesting. And then, you know, because objects can be passed around, that means you can pass around instantiations of the interface. It's pretty simple, isn't it? Yeah, so it's an anonymous type. I'm trying to think of like where this could go wrong, or even how it could be written a bit nicer. Like, so first of all, what would it even be passing in this case? Like, what does this even do? This just generates a list, right? Yeah. So I'll call it like a fib generator or something like that. Pretty much, actually, yeah. Like a Fibonacci generator. So that'd be the function, right? I mean the class, or the type. Or I could just have a open function called genFibs, and then it will call fib. I mean, genFibs is very like generic anyway. Like really, it'd be called like a Fibonacci list generator. But then you could do that, and yeah, like kind of define that. Very strange. Is there another way to do this? How do I do this? Like, how would I do this without thinking about like this particular method? Like if I were to just, like, let's say I had this kind of Fibonacci thing that could yield, right? I would have to define some kind of thingy, or pass it directly into fib, but probably don't want to do that. Because like in Haskell, it will return a list, right? As just like a generic way to get a list. But to yield gives you more flexibility. It means you can do anything with it. Like you don't have to receive the list in the first place. So that's really more efficient. It's to lend it even more intrigue. How do you spell intrigue? Intrigue. I don't know spell check. I don't think so. Intriguingly. Yeah. Okay. So intriguingly. Even more intriguingly, this means that a Fibonacci generator does not have to return a list. Does have to represent its result in a list. Instead, you can so like this literally removes a layer of translation for cases where I want to do something like just directly print the values. Of course, it's probably more efficient to still print the list at once, but like I can still like store them in a buffer and then print them, you know, like as strings. So yeah, very, very interesting. I assume this would be more performant than operating from a list, or like a vector, like whatever, like contiguous or otherwise. So yeah, damn. But you need to have a definition for yield. So yeah, so the way I would do this naturally, like without thinking about this, is just pass in a yield handler to the function directly. But here, unless you just define it kind of without it. It's interesting. It's very interesting. So you can specify context and call interface functions as just Effect is the nicest syntax of the algorithm effect languages. For me, the separation of the handler and the effect is a big part that is handy. Since now you can customize how stuff will be handled, and more you can capture the entire continuation from which the effect needs to be performed. Wow. Okay. What? You can now capture the entire continuation from which the effect needs to be performed. Okay, I don't know about that yet, but... Wait, this is very interesting. Like, I feel like we're finally getting somewhere, you know? With an effect... Okay, when an effect operation fires, the handler receives the rest of the program. Everything that would have run after do yield as an implicit argument called resume. Right. And you can call resume with unit. Why unit? I guess because like there could be a case where you resume with a value of some kind. Calling resume, sorry, I'm skipping ahead. For an effect to yield xa, unit handled in a try block of type t. Resume has type unit to t. You can hover, always. Oh no, for this effect. Because it returns unit, right? I assume. Unit handled in a try block of type t. Unit to t. So resume returns t. But t is listed int. Okay, I don't understand that one. You can hover over resume in the editor to always see the exact time. Can I do it here? No. So there are three ways using resume. So not calling resume aborts the producer, and the continuation is discarded, as was throw above. Calling resume once is the ordinary case seen in generators and state, as with yields above. The producer continues with the value passed to resume. Calling resume multiple times runs the rest of the computation multiple times. This is how non-determinism and backtracking work. Well, why would I call it multiple times anyway? I mean, that's a state, right? If I resume, I'll do it again. But if I call resume, will it do it with the next value, or will it just do it from the same point? I don't know. For more details on effect handlers, see the effect handlers page. That's here, right? Yeah. Man, this is so much more. This is just so much. I mean, it's just better presented for starters, which means it's less confusing, which means I can actually understand what's going on. But also, the syntax is a lot more intuitive. The other part is resume, right? But is there more you can do than just calling resume? Well, besides not calling it and calling it multiple times. So a singleton operation. Often we want to declare an interface that is entirely defined by just one operation. So we want to. Like a single abstract method in Java. In this case, you can declare it as a singleton operation using the effect keyword. This is syntactic sugar. And a singleton effect declaration is exactly equivalent to an interface with a single operation of the same name, and the concise handler syntax with tel, a shorthand for with tel. Define tel equals. Yeah, okay. Effect tel. Interface tel. Again, I still like the word effect, because effect sounds to me like side effects. So the moment it's anything but a side effect, it's just a bit weird. The handler for a singleton effect uses the same concise syntax. Yeah. Here prog is expected to be passed a computation, block, and not as a value. You can read more about their distinction in the section about computations. Using interface tel. Why is it a unit function here? Define yield. Oh, just to say you pass a numbers function, I guess. Okay, fine. I might steal this anonymous function syntax. I'll think about it. Using the function tel time that handles the effect tel of prog, we can write the following program for measuring the execution time for computing the first 1500 Fibonacci numbers. Tel time, val start to tel. What's this? Tel time scope. Val start equals do tel. Val fibs equals generate fibs. Bench timestamp. Where's that coming from? And do tel. Print line took show and minus start. Yeah. That's a list, right? So fibs.size, I guess show is just converting it to a string. Okay. Yeah, this is nice with syntax, I can't say. So can I run this? Was there an arrow there? Was that there before? I can edit this. I'm not sure it's working as well as it should be. Okay, it worked. Oh right, because it was generating the numbers. Yeah. This is... I can edit this. I can edit this too? Okay. Oh, because all of these are used here, right? I guess that's not the most clear thing, but... We're frozen. Oh, we're back. Okay. Chaining handlers, we can decompose gen fibs into a more general helper function collect that helps that collects yielded values by abstracting over the generating program. What is yield, by the way? Like, we didn't actually define yield, right? Or did we? Oh no, we did. It's just like yielding is just like, yeah, like it's literally just yielding. So this is effects for a different purpose than I sought them out for. But it's still interesting. But like, it's just not what I was looking for. Collect, that collects the values by starting over the generating program. Collect. What? Is this the trailing lambda syntax? Can't tell. Prog unit yield A, list A. Var yielded equals empty list. Var count equals 0, try prog with a program with yields, yeah. And there's filter. How is program passed? Oh, because that's with syntax, and then fib is there. Yeah. So this is how you do lambda arguments, or function arguments, which is actually decently interesting. It feels just very weird though. Like, I don't know why it needs to be like that. Obviously, it says it in the previous sections. I just haven't looked at it. If keep x, do yield x, resume, else resume. Filtering. We can avoid the nesting of higher order functions like collect, blah blah, and write. Yeah, I just write with. So with collect limit, with filter, x to x dot mod 2 equals 0, fib. Run this. Yeah, that was much faster. So these are all the even numbered Fibonacci numbers, right? Surprise it. There's so few. With syntax. With asymptotic sugar, it passes the remainder of the current block as last... Oh, okay. This has deeply nested calls, can be written as a flat, non-nested sequence. It's interesting. Again, it's like a denesting strategy, which I do appreciate. But what did I say before? That like it feels like piping. Like I could pipe fib into filter and then into collect. Right? Would that work? Well, no, because with creates an anonymous function, right? That would call that, yeah. So we'd have to pipe the anonymous function into filter and collect. I don't know. I'm still on the fence about that syntax. So let's go back up here. I don't know, actually. Let's look at the introduction first. So you got hello world. I don't know why this example in particular is so slow. Like it's printing the line. Like, is I/O really slow to do? It shouldn't be because it works fine for the other one. So like if I edit this, right? I mean, I don't know what I would do here. Whoa. Define. Yeah. I don't know, like, can I do this? Boom, 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 boom. Expected this, but got this. What? I can't have lambdas. How do lambdas actually work? That works. Why can't I define the lambdas function and call it? Oh, whatever. Syntax started by Scala. Statements are semicolon separated. Okay. Lists. There's syntactic sugar, pattern matching, match, case. Application. What's that? What is that? It's not a unit, is it? Oh, is that an empty list? What? That's really weird if it is. And call it. One, two, three, four. Yeah. Okay, whatever. So language tour, hello world. Yeah. Okay, values. So they're pure. With no side effects. Wait, what? Terms, so values or terms that are pure? I mean, I guess it makes sense, right? I don't know how you'd have an impure one. Like, a value can't... I don't know. I don't know. Most values of built-in types can be printed with print line. However, print line is not defined for others, e.g. char or user-defined types. You can't print line char. It's a bit strange, but okay. Manual definitions of show for any specific type can be written and will take priority. Yo, I feel like this could use some concurrency, you know, rather than blocking the entire website. Although, I mean, I can still scroll. Manual definitions of show for any specific type can be written and will take priority, but effect will generate a show function for types that do not have one. False. Right, okay. Variables. These is the var keyword. So you have val and var, which is fairly nice. Although I do wonder about having like just mute as a keyword instead. I do kind of lean towards that. And differs for functions. Right. So does that mean Scala at that point? It's not permitted to initialize variables. That is, there are no mere declarations of variables. Ooh. Okay. Why is there a semicolon in that particular example? I wonder how that works. At runtime, usable variables are allocated on the stack. Okay, that's really different for some reason. Records, so tuples is this, yeah. You can destruct it with match. T-match. Or irrefutable pattern matching in the left-hand side of val bindings. So that there's no like .0. A record is named and needs to be declared first. So there's no anonymous records. Like in the case of tuples, records can be destructed by employing pattern matching, or by using irrefutable pattern matching on the left side, or by using field name accessing. Honestly, I'm fine with like .0 and .1 not being allowed for tuples. Like, if you need to access it by name, give it a name, you lazy sod. Maybe not though. But anyway, it'd be cool if I could just do this. Although it's kind of problematic that it can't be referenced, right? Like, it needs a name, low-key. Not really, though. Like, the name could just be type of effect, you know? And then for the constructor, it'd just be x equals 1, y equals 2. Records can be destructed by employing pattern matching. Okay, data types. Algebraic. Some types, potentially multiple different variants, can be expressed by algebraic data types. Yep. A data type starts with the type keyword and is followed by the name of the data type. File equals file. Yeah. You have the pattern match on it. A pattern match consists of more clauses limited by case. Yo, match else is kind of wild. I've actually never thought about that before, having match else. Like, I thought about having else, like, inside, but having it outside of it, like this, it's kind of interesting. Or just use a, yeah, case blank. I mean, that's why I don't want to support else, because like both would work anyway. So just have the empty pattern match, you know. Also, it creates an issue with exhaustive pattern matching. Right now I have it so that if and match are one statement, just if. And if you initiate a list of cases, then it's exhaustive. If you don't, it's non-exhaustive. That's why I have it right now. So that else we can like have to be inside anyway. By that model. I spent a lot of time thinking about it. Like a lot. You can use partial matches in positions where a bool is expected. Ooh, there is if file is. Holy moly. There's an is keyword. This is huge. Do you know how few languages have this? Like, it's actually, it's quite a revolutionary feature. Low-key. There's an error. Well, because I couldn't have expected too much. There. While let? What? while D is directory children. Like an entry over lists. What's Rust while let? Loop, match optional. So optional is sum 0, okay. Why is main? Oh, because it's runnable. No, they're both runnable. Why is main only here? Can I edit this? So while let sum I equals optional. Yo, what am I matching over? Right. Yeah, so you like repeat the condition each time. Just like Rust has to use some special syntax for it because it refuses to have an is keyword. Yeah, pretty cool. Lambda match. You can directly patch and match on the single argument without needing to bind the parameter. Like in Haskell? Or OCaml. I think OCaml with the function keyword. How does this work? Huh. It's interesting. Yeah, lambda match. But only on single arguments. I mean, if it's multiple arguments, I guess you can match on multiple anyway, but okay. Yeah, I'm honestly not a huge fan of single match, or like single lambda match, whatever, however you want to call it. Like, file system. Yeah, like I'm not bothered about that as a feature. Loops. Almost standard built-in while? What do you mean almost standard? Okay. A while loop consists of a condition on which to continue the loop, the body, and an optional else branch that is run when the while loop ends. Why do I need what? Why do I need an else branch when I can just put it afterwards? Am I missing something? Like if I run this right now. Like how is that different from just doing an edit? From just doing this. Like, it's the exact same. Okay, a while loop consists of a condition on which to continue the loop, the body. I swear I just read that. I did. Furthermore, there's a loop function defined in the sum library you can use for infinite breakable loops. Okay, it's a function. Loop Yeah. Oh. It uses this for arguments. So this one. It's like invoking the runtime or something. Why is this one so much less popular, by the way? It's so much better documented as well. And it seems to be at the same age. So I would do this. No. Okay. I don't know then. There's a blog. They made a whopping one thing so far. Yo lambda. I don't know. Case studies. Naturalistic DSLs? What? Say John, Mary that loves John. With effects. John dot said, Mary dot loves me. Okay, I see. I believe this also happens in. You can also do this in OOP. John dot said. Man. Break can continue. Wait, L dot break. Oh, we're naming the loop. What? They have the usual semantics, except that you're handled by loop as operations of the algebraic effect control. Yeah, that makes sense. Having it be an effect. Additionally, the standard library also includes the functions each and repeat. Oh, like for each. At each iteration, the current index is passed. Oh, L dot continue. Wait, so what's L? Like the tag of the function or something? Are we naming the effect in this case? Repeat just expects one value argument that controls. Okay. Yeah, you bind a label. L to continue. Why can't I just do break, you know? Like with this function here. Why can't I just do continue? Main cannot have effects but includes effects. Okay, well whatever. That's kind of funky how I need to name it. Instead of just like implicitly going for the smallest scope. Functions. There is uniform function call syntax. So UFCS, whatever. So I can do 5.fib. Still not convinced about that. To define a type polymorphic generic function, like the identity function, type inference does work here. Okay. Oh, how are lambdas? Okay. We finish this now. Commutations. Paul Levi's call by push value, effect distinguishes between values and computations. So, in effect, blocks or computations or functions, instances of interfaces or objects, and regions. Functions and all the computation types are second class in effect. What? Dude, why is my thing so white? Like, why is the lighting so like oh To make this difference explicit, we pass values in parentheses, e.g. F42 and computations and braces. I see. Yeah, it's the same difference, right? As with Koka. Function, yeah. The block parameter f is enclosed in curly braces and syntactically separated from the value parameters. Why is that important? Well, multiple value parameters are separated by commas, multiple block parameters are expressed. Yeah. Like, I don't know. In the previous example, the block passed to my map did not use any effect operations, and the signature of f in my map did not mention any as well. Do yield. Okay. The boom on my map itself means its color needs to handle no extra effects. It might look like it says f must be pure, but that is not the correct reading. It means that f imposes no requirements on my map itself. Any effects f actually uses simply propagate to the call site of my map, where they are handled in the lexical scope where f was written. Contextual effects polymorphism, my map stays effect agnostic, regardless of what f does. Right, so in Koka, this would happen instead by having e here for effect, to imply that it's just a generic effect. But then like you have to put it here as well, somehow. Comparison. Okay. What is call by push value? Call by push value. It's a paper. It's a new paradigm based on the slogan, a value is, a computation does. We claim that CVPV provides a semantic primitives from which the call by value and combined name paradigms are built. The primary goal of the thesis is to present evidence for this claim. Holy moly, this is long. Wow. Oh my god, there's more. Okay. But there's pi calculus. The eta equation. Yeah, so like this is the kind of stuff that like I just don't understand how to read right now. Like m equals a function that computes on m or something like that, or like has the effect of m. I'm not entirely sure. Like gamma, like what's going on there? Pop x, push v. Like I'm sure this is like an interesting paper, but I don't even know how to like approach this. Let x be 3, let y be thunk. Okay. Objects. Effect features a simple object system. Let's assume the following interface. Interfaces are computation types, and we can write a program that expects a counter to work on. It's a computation type. Define use counter, print line, increment, yeah. Oh, C. So yeah, so we pass the counter explicitly. Whereas if we did do, we would need to pass it explicitly. That's weird though, it's like counter being an effect is just a bit weird, you know? Like, it's really just like a different way of doing object-oriented programming. We can create an instance using new. Define counter equals new counter. Define increment. Okay. Objects and handlers. The association of objects might be reminiscent of how handlers implement effect signatures. This is no coincidence. There is a close correspondence between interfaces and effect signatures. So these are equivalent, right? Use counter, counter. Or just do this directly. Try use counter with counter. Okay. Captures. Since computations can capture capabilities, they can only be used where those capabilities remain in scope. What does second class even mean? For statically preventing capabilities from escaping their valid scope, effect tracks capture capabilities on type level and verifies. Boxing. Consider the following example where divide is being passed an explicit capability. See, this uses exc for exception, not exn. If n equals 0, throw a O. Yeah, handlers implicitly or explicitly introduce capabilities that are then passed to the position where an effect is used. Here we pass it explicitly. Yeah, I get it. Uh-oh, error, okay. What happens if you try to return the capability? Try exception with exception. Define throw message equals panic message. Is that what panic does? Use box. We break the lexical effects handling reasoning since exc is only defined when within the try body. We must not return a function that closes over such a capability. Oh my god, I'm so white, bro. why is the lighting like that on my camera? Okay, to prevent capabilities from escaping their scope, effect tracks captures. As a boxed computation, you must unbox it. Okay, I'm not really following. So if I were to edit this, to remove that, yeah, there are multiple overloads. So then I remove this as well. Possible overload. Right? It's weird. Holy moly, how many overloads are there? Okay, boxing. Effect distinguishes between values and computation. So you can pass computations, but you cannot store them, or return them, which means you must box them. Box second class. Interesting. So to use a function to pass it around, you need to box it. That's actually quite interesting. So looking at this, could I even just like... Of course not. Because like one concern I have with functional syntax is that usually they call functions without using the parentheses, and so it can be a bit confusing to like to disambiguate when I'm passing a function versus calling a function. But if you make passing a function or storing it, whatever, require box as a keyword, that's rather interesting. I don't know if I like it though. It runs two functions in parallel. What does this mean? Is that a comment or something? Since parallel wrong expects two arbitrary blocks as arguments, these blocks may capture arbitrary capabilities. Right. So here's boxed. What's at that? Oh, pure. Okay. So, wow. So here they're to be executed. Here they're actually just values. Functions as values, being first class. The type checker will reject calls, where we try to pass functions that close over capabilities. This captures I/O, so this call does not type check. So if I run this, I should get an error. But what if I make parallel allow I/O? Not okay, yeah, so I implemented, I guess. Hold on. So could I do this? Because this doesn't work for some reason. But what if I box it? Got unit at I/O. Right, and then I call it. So here I've turned it into a value that I can call. I see. Bit complicated, but okay, I understand. When programming an effect, it can be very confusing that there are two different aspects of the type system that ensure type safe and effect safety. Effects express a requirement of the context. Captures express a restriction on where a computation can be used. In other words, an effect is an open demand, a capture is a fixed capability. We need to edit to see that kind of stuff. So box closure is at x.io, unit at that. This is just unit get at io. Don't understand that. Capture sets can contain at least 3 because elements. Consider a function using the built-in function println. The function hello world captures the resource IO, since println requires / captures the IO resource. Is that implicit? Yes. So yeah, I don't understand that. at IO. Why is it not just unit or void? That's fine. Yeah. So there's unit. I would like slash IO. No? Or slash IO? Did you mean IO? I did. What? I don't understand that yet. I don't understand the difference between these two. Like, I get that unit IO means a function returning unit with the IO effect, but I can't make sense of the at IO syntax. Something about, what's it? Captures. Hold on. You can pass a value into the continuation. Resume. Scheduler. That's a case study. Try with define yield, define fork. This is Python. It's not lazy evaluation. Is it not? I mean, like, I guess it doesn't cache the value. It could do that. Why is it not? Effect doesn't have a primitive IO effect. Effects is something one can handle in the program, whereas IO is handled by the runtime. Its handler is already predetermined and you can't change it, but it's still not pure. IO is handled by the runtime. Which we need to know for reasoning about the program. I've seen this more, right? namespaces, namespace keyword, double colons, okay, regions, resume true, resume false. If flip multiple resumptions in mutable state needs to be handled with care, such that the state is appropriately restored for each resumption. So it resume true. Set x equals 2, then print 2, and then resume false. If we define x within the handler, the behavior is a different one. Oh, because I guess updated. But x backtracks. Yeah. Okay, I expected that to happen. Yeah. Because when you store the state, it's what concurrent systems do. They store the state so that you can then come back to it and resume. So like the register and the whatever values are kept or stored somewhere, and then you have like a snapshot of that moment, which is pretty cool. And that's like what a continuation is as well. The continuation is that store. I don't like it being called a continuation. Like a continuation would be like the action of continuing, but I believe that's correct anyway. Int at x. Right, so the at is for variables then. Int at x. Region. Holy OOP, dude. A region looks a lot like a class definition, doesn't it? Their second class. What? That's so weird. Am I crazy, or is this literally like what objects do? I mean, obviously the difference is that like you can't call like r.x. Or can you? No. So it's possible to allocate a variable globally by using the reference module ref. Yeah. With this, it's possible to write a program which is normally not possible. X.get, okay. We can return a closure that closes every mutable variable. Only possible because X is allocated on the heap and subject to garbage collection. Oh, so it is garbage collected. Okay, implicits. Hold on. This has the advantage that for the most part you can sprinkle debug logging around without the compiler being overly mad at you for doing so. It does, but I didn't quite grasp it. They can only be used where those capabilities remain in scope. Right? Is this basically an explicit anonymous function versus capture versus closure distinction? Some functions need additional parameters that can easily be inferred based on their name and type. For example, a sort function I want to get an order as its argument. Oh, compare int. That built in. Why is it put like that? However, often there will be a function compare in scope, and we could simply simplify the call if this is used automatically. In effect, you can instruct the compiler to generate the block parameter like above by putting a question mark in front of the parameter. So compare is a question mark. We use the standard library sort here, which gets a less than or equal. My sort. Again, like, OOP just makes this a lot more cleaner, because then like it's clear where we have these defined, you know? Whereas here, like, it's just using like global references to things. It's a lot less clear to read, and like to follow, even to understand. So I'm not a fan of that. So why is it equals? Okay. This generates something like the following. Name-based parameters also will be passed with functions, so I can get calls implicitly like this. Wait, what? Oh, that's compare. Okay, whatever. Values, question mark. This feels so strange to me. Because having object fields rather than, I don't know, implicit, rather than pulling, yeah, it's just weird, it's just weird. Lazy validation is a particular example of validation being suspended. Not all suspended computations are lazy. You also need for some computation caching. I was thinking about caching, yeah. So that's the difference. Also, this is so strange to me. As far as I understand, effect lets you just like, I don't know, implicitly take definitions that are in scope. Compare this to just using OOP, where that scope is clearly defined, and in some cases explicitly accessed via self.foo. IRC Haskell lists have a blurry line between data list and code data stream iterator. I thought caching is a requirement for this evaluation, but it's nice to have. Of course. Like, it seems like a huge effort to avoid just using objects. And like, you know, not to glaze object-oriented programming, but like, it's quite intuitive, you know? And it's not like there are performance issues or anything like that, so like, I don't understand. But it's interesting. Boxing, the value parameter is a box type. This is expanded to box. And expanded like block parameters, so the following works. Oh, it's unbox as well. What? What does unbox mean? You have to unbox it to call it? I don't know. Source positions, when a function takes an implicit parameter with its name source position, it will get the result of calling source position within the file name, start line. Okay, call IDs. What? Okay. That's fine. Wait, so is call ID always just call ID? Like, is that built into the language? It must be. IO. Uh-oh. Node.js. Hold on. Wait, is effect a JavaScript language, like compiles to JavaScript. If you want to open a file, we don't have to choose between a callback-based variant, a promise-based one, or direct style one. All of them are derivable from a single operation in direct style. With onIOError.panic, read file, read file, read file, read file. Yeah? Why is there a semicolon here? This is synchronous. I assume it's something that the files aren't in scope or something. I can't read what doesn't exist. Or not. So, can I remove the semicolon? I can. If you want to swap two pairs of files, we can do this sequentially as well. We can also use the existing implementation of swap and run the two swaps concurrently with promise. Okay, I don't know how that works, unfortunately. Just a way to wait. Is promise just like try? Or like, sorry, like, actually what? Like, is a promise like a task? I assume it's a different concept. Okay, FFI. Extra and def, okay. Oh. There actually is string interpolation. Extra and type. Okay, extra and include. But do they like all have the certain effects? Captures. You manually okay, so you manually, yeah, that makes sense. Okay, sure. So that was the language tour. A bit confusing towards the end there, but definitely a lot more straightforward. The core concepts. Effect safety. Yeah. So like the requirements is what I'm interested in mostly. Effect handlers. We can express advanced control flow as libraries in the language. Polymorphism, bidirectional. Interface config, this is exception. Okay, got some case studies here, examples. Evolution. So there's a paper here, 2020. 22, so implementation. Okay. The caller ensures that you get a definition from its scope. Now that the callee gets access to the caller scope. Calls like foo elaborate by the compiler as foo context. Foo doesn't get the message magical s scope with access to s.context. Yeah, it's just overloading. They're not used inside a lib. What's spop? She-Ra and the Princesses of Power? Who's She-Ra? Sounds familiar. Or yeah, Yeah, I still like it. Like a trait system, you know, that's nicer. But maybe it's just what I'm familiar with. Closest, like thing string and cx string would resolve cx. Ah no, let's go distance makes way more sense though. Why did I see something so horrifying? Okay. Well, that was an interesting deep dive, you could say, into Koka and Effect. I mean, I say deep dive, like, I looked at the documentation, but like, that is pretty much all of the documentation there is. So, I'd say it's a deep dive. Of course, I haven't used the languages yet, but I don't feel like I really need to. Would I use these languages? Probably not. They're interesting, but I'm just not convinced by effect handling. There's some interesting ideas there on how you can orchestrate async and exceptions and all these other kinds of things, but ultimately there are also alternative ways to do it. So I don't know, but it's good to have in my mind now when I go about working on True more. So yeah. So any questions? Any questions? Like, Java? What? Why? Or thoughts? Classes can't have methods, right? So I'm thinking like, you could just create a language where async and error handling just like are designed carefully to work well together. Effects are so useful for concurrency, but again, I just feel like effect handlers just really are necessary. Like, not even like not necessary, but just not like they're overshadowed by better ways of doing things. So it's interesting, but I feel like effect handlers just aren't that important, you know. I feel like effect handling isn't all that useful, as it's kind of overshadowed by OOP, whereas effect notation on function signatures is useful because it both documents and informs the compiler of things it may need to know for stuff like async. Effect tracking, effect handling. You kind of one without the other. Koka has both Rust, async, FM, and for results gives you tracking with ad hoc handling. Yeah. Java checked exceptions give you tracking with a very restricted one-shot handler. On overshadowed by OOP, exceptions are a restricted effect handler, non-resumable, single effect type, dynamically scoped. OOP languages didn't replace effect handling, they just shipped one hard-coded instance of it, and never generalized the pattern. Full handlers add resumability, pluggable interpretation, and composability. If for true you merely want the documentation to compile a hint value, knowing a function as IO can suspend or touch a shared state, you don't need fully resumable handlers to get that. A lighter effect type system built to automatically control flow is a simpler design. You'll be giving up resumability and pluggable interpretation. I mean, I could just... Nah, hold on. See, nah, hold on. Looking at this wouldn't work, because yield calls resume, but resume needs to know that it's been interrupted in the first place. Like, any effect can cause this to stop and then need to be resumed. So, like, they all yield, basically. They all yield. Yeah, but, Yeah, okay. Okay. Yeah. Okay. Wow. So I'm gonna think about that more and see how I can apply that to true language, like my language I'm making. I want to have, I kind of want to have like asynchronous programming as a default almost, and see how that works. Effect handling, yeah, like the yield is quite handy. Having that as like a built-in construct, just yielding, and then you can resume from context. So that, I mean, that can be used for async, but then for exceptions you just disregard it, right? Just disregard the yield. The thing is though, I don't want to... I just don't want exceptions. Like, I don't want exceptions. I like result types. So, can I think of a syntax that gives you like result types-esque kind of handling? Because I mean, like, for me, it's mostly a syntax thing. I just don't like try catch. Because like, with result types, you have return, right? And return will return. But then like, you can only return. I can't like do something special. I mean, I can, to be fair. But like, I can't resume. Like, if a function returns a result type, like, there's no resuming the function, because there's no continuation that's stored. Like, I can handle the error and do nothing else. Like, I can't continue, or like give it a value, you know? So it's definitely a very powerful thing to be able to resume. But then, like, do I have to do try catch? Or alternatively, just pass them as function arguments, right? Like, pass the handler. To be fair, I do see the advantages in effect handling. You get yields, you get yielding for concurrency, you get resume to inject, to return, to have functions, ask for more information. You can ignore yields. You can not continue to have exception-like behavior. But my main issue is that I quite frankly dislike exception syntax. Exception try catch syntax, as I'm sure many do. And that's what I've seen in effect. However, I may be more swayed if there is alternative syntax that is nicer. OCaml 5 has... Wait, yeah, I forget. OCaml 5 literally has effects, doesn't it? That's so weird. OCaml, man. OCaml is quite the language. Match commutation with... And I mean that in a good way. Effects become just another pattern to match on, alongside your normal return value. No separate syntactic category from regular pattern matching, feels like escape hatch syntax. What? Oh, like... If it returns results, I guess? If it returns a yield, then do that instead. Right. Surely I can do this then with values. It's just having the ability to continue. Right? Yeah, like, imagine if Rust, with result type, you could return an error or something. But I continue. Hold on. Does Rust support continuations? Like, can I return? Like, can I have a function return continuation t c? No, return a continuation t. No, a result t continuation. And then call that continuation to resume type thing. Because that way, you get the as values. I'm just thinking, because I've seen how OCaml 5 handles effects, and it just matches on a function's result, which is quite cool. Why is it highlighting on my Claude? Oh, because, okay. I like how the highlighting just gives up. True. Yeah, that's true actually, lifetimes, right? But unless there are conditions. Unless there are conditions under which it wouldn't mess with them. This is syntax sugar magic, same as exception magic matching in match with blocks. But yeah. Same as exception matching in match with blocks. I don't know what that is, but okay. What the? What a strange hair biology, bro. What is going? Like, what's even? I'm just a bit confused. Still, my main issue with effect handlers right now is the syntax. I really don't like try catch. So I'm wondering if nicer options exist. Cookies is with, yeah, so we saw Koka, which reads much more like ordinary control flow than exception handling. So with A and B handler, fun, flip, true, false. ask. Well, what is that example? What the hell? Is that recursive? What's amp? I'm guessing amp is the effect. So then why is it handler? Is this even correct? Handlers are declared with... I don't think that's correct, is it? Or maybe it was once upon a time. And calling an effect looks exactly like calling a function. Not like throw. Yeah, that's the issue in that it does look like a function. That's a big part, but then just don't call it effects. That's a big part of why people find it nicer. The effectful operation doesn't visually stand out as something dangerous, it's just a call. Unison calls them abilities and handlers runs. I don't see unison. The common thread across the syntaxes people actually like. Performing an effect looks like an automated function call, not a special throwaways keyword. And handling looks like matching or a with block over operation names. Huh. How about unison? Lang. What about result types? Like if Rust had a resumable T, right? Just that I could have, I don't know, function, oh cool, do thing, no, no, like a resumable T, or like a like a continuation, right? Do thing, continuation T, and then like function main. I don't know, do map do thing, yeah, no, yielding, right, is yielding result x, then print line x, if it's yielding continuation C, then print line yield, and then continue C, right? Flex, This looks so Rust-like. What the hell? Is Rust's docs like a... What's this powered by? I/O. What? There's regions. And there's effects. Bro. Wait, pole bending's a thing? What? Every function in between has to know about yielding. Well, obviously. Because like, it could yield. Why is that a problem? But the whole point is that it propagates. Yielding result to E. Right. That's true. You can handle them independently, which is quite nice, isn't it? But even if I compose effects, like if I'm either yielding a result, right? That's fine, surely. Right? So like if I yield a result T, then you know I yield a result T, that makes sense. If I result with a yielding T, then I'm returning something that either yields or continues. Like, if I have a yielding T, it means that every time I yield, there's a chance there's an error. Whereas result yielding would just be like a normal or an error, right? Like, it's pretty straightforward in that sense. But how about for stuff like writes, right, or reads? You know, like those effects. Or like non-deterministic, you know? Like there, the return type isn't that. It just returns what it is, which is a value. But marking the function as non-deterministic may be helpful, may be important. You could wrap it, like have a non-deterministic wrapper type, but then it's like, You could. And then you get well, then you need to unwrap it. And what's the point of that? I almost shouldn't be able to I almost shouldn't be able to unwrap it if the function requires a deterministic output. Unless I just can't unwrap it. It's I cannot get the value inside. I have to just mutate it more or less. I mean, isn't this like the Haskell philosophy? Yeah. If a main do let rand equal gen rand, it can't be unwrapped though. So how do I access the contents even? So it have to do what Haskell does, which is unwrap it, but then require that you return another thing. Pretty much, right? Sorry, I'm not showing my screen at all. Or scheme. Of course, it's not gonna be nice. equals some caveats. Sorry, I'm just gonna think. Like, let's say I want to access a non-deterministic thing, right? Non-determ. An object. I could use an operator. Like, it could support a bind operation, I guess. Bind in Haskell is IO_A to IO_B, right? So like let run equals get ran, and like ran dot bind, right? Right now for function. X type key, right? We can match on X. Say sorry. Yeah. Easy to well no, you wouldn't match it, sorry. Yeah. Deterministic. Right? From. Like format X equals random number equals X. But then how does async bus work? Yeah. So like this works as just a more Rust. any monad. Right. I'm wondering if X could be tracked through function returns types of fishes by two types, other than special independent signatures things on a function signature. Wait, is non-determinacy actually a real thing? Wow. What if I could compose them? Oh, so this is fine? Those downsides you mentioned aren't downsides though? I mean, what Haskell those? Yeah, but the order being different is also important, right? Okay. So there's a runtime that pulls them. Okay. Okay. Java. Okay, so this is wrong. This is the correct way to do it. But look at how much we're like. This actually is quite simple. This one is like run let secret with handler secret, handler guess, handler terminal. Passing terminal and calling it. That is like OOP. Strange. Okay. Yeah, I don't know. I'm gonna think more about this. But it's interesting, isn't it? Yeah. It's interesting. Actually, here's your unison, by the way. Unison. Hello world IO exception. Oop. Okay. This is docs, I guess. But is there dark mode? Why do so many websites insist on being like so bright white and not have a dark mode toggle? It's actually insane. Could be force it somehow, but forcing it never looks as good as like as readable as not. This is a function. It looks like Haskell, doesn't it? Why is there no argument here? Hello world, IO exception. Hello world, print line, hello world. Is compiler or an AI? That's weird. So this isn't just a language. This is like a way of a new approach to refactoring. Is there even a language here? Wait, this looks so like AI generated. This was this website. The random emoji are not helping. orthodox. Okay. Abilities is what they're called. Try catch. Over here. I don't know. Okay. Yeah, for real now, for real now. So, I'll look at this with true. I'll see what I can do. I mean, the important effects are the ones which the compiler would benefit from knowing about, right? And also, like with when you write functions, like having like function coloring, you know. So like if I write to I/O, that should be an effect, because maybe I want to have a pure function which can't write to I/O, or like these can be used like done as attributes as well, which is the weird thing. Oh no, not attributes, like modifiers. Like async is a modifier that says a function can be async. I don't know what that means though. Like what? Like I guess an async modifier just means this function can be awaited. But like that's the thing, right? Like it gives capabilities to the function, straight up. Like I can await the function. Which is weird. Like if you think about it, that's almost like having a like an OOP, having a type derive from the awaitable interface, right? And then if I derive that trait, whatever, and then use a default implementation, I guess, then I can now await it. You know? But in this case, it's a function. It's like, am I deriving an interface for the function only? Kind of. I guess. I don't know. Something to explore. And then, like, with the function then, like, can I... But then, like, if anything calls my function, it needs to also then put that effect. So, like, I don't know. It's quite deep, I guess. Yeah. I'll look into it more. Well, I'll not really look into it. I'll experiment with the syntax with true next. Because it's very interesting and I want to... Yeah. I want to make a cool language. And this could be it, you know? I mean, I've already worked on syntax, so that'd be quite cool. But then if I can get, like, some really cool, like, effects for concurrency and error handling and mutation safety and all that kind of thing, stuff that, like, Rust can't do, you know? I could be cooking. But I've a lot of learning to do in the process, so... This will be my magnum opus. Subscribe to see more developments, or to see developments of that, and also more research. 5-hour video, dude. 5.5.